characteristically, I was muted for the beginning of that. That's always nice. That's why we do these little pre-flight checks. Maybe most streamers run into that when they start streaming and they go, oh, my timer's still up, but I forgot to unmute. I don't do that. I talk to you guys during the beginning of stream, and so you get the full bother experience of having his audio all messed up. I was just saying about, what, 5 seconds into my brand deal, and I think I already violated something by not putting, I don't know if it's Fusion360 or if it's Autodesk Fusion. I don't know which one it is. Let's update this. But this song goes hard. I like it. It's a little loud on my monitors, though. It might be a little loud for you guys, actually, because it's supposed to be like 50%. But it goes so hard. I'll knock it down in my ears a little bit there. Did I not hit update now? We're getting this out of the way. We're updating Fusion because we're going to be using it today. It's going to be our mainstay of the stream because I got my license for Fusion360. They gave me it. The whole program. A $480, $90 value per year. So I got to do, like, every 1.5 months, I have to do one of these streams where I sponsor, but let's be honest, we've been using Fusion360 for everything. Autodesk Fusion, I should correct that. Yeah, wait, what happened there? Where's my dashboard? What the? Okay, there it is. Yeah, we're doing some PCB design today. I gotta get my copy up to date and then load all my stuff from the cloud. Oh my God, it's a big update. 10%. Well, we're doing it during the intro anyway. The intro usually lasts a little longer. My collar is messed up. I look like I'm dumb. Hold on. Minimally presentable to be a streamer. Actually, that's not true. I was thinking about doing the VTuber that Pixie K made for me for these streams so that I could go full screen with Fusion instead of the sort of squished view because of my vanity frame and this stuff up here. I could potentially, but then you guys don't get to see the shop behind me or like what we're working on and measuring stuff with calipers and things like that. So it's often a more active process. So I guess I should probably spread out and you know, have the restricted Fusion view. Fusion likes to use the edges of the monitor quite a bit. It likes to use the width of the monitor quite a bit, and that can be a little frustrating for me because I take that up with these screens. But we'll get by. We always do. You know, like when you have a huge design, your browser stuff is like taking up that whole column, and then if you look for another model to put in there, you've got even more space that's just being consumed by Fusion's shenanigans. But again, these windows go away, so whatever. This thing is going to take a long time. Oh God, it's already at 80. Well, 83%, but when it gets to 90, it stays there for like an hour. Let's see. Let's pop out YouTube. I think I hit start all. Are we streaming? Yeah, we're streaming on YouTube. Let me check to see if I've popped up in my own YouTube window. I have indeed. So let's open that up and see whether or not... Oh, wow, what a terrible... Okay, it's trying to load. I don't need you to load the video, YouTube. It's going to make me watch, like, my own ad. There we go. Pop it out. Look at that paid promotion thing that came up. Oh, no, it went away. It was up. Bonk. Okay, there we go. I think for the times that I use Fusion360 that I'm not trying to have it be part of my requirements in order to have a license, I think I can drop the sponsored part because we won't be, well, I don't know, we'll see. It doesn't hurt to put it up and it just gives me credit. 94. How long are you going to be on 94%? Forever. Forever and ever. Wow. So I still need to order parts for this thing and Dave's thing. Oh, if only they were aware of how much I've worked on these things. It's so frustrating. I can't seem to fix one. We need the switching device in this one. And then for both of them, I need the LM117200, which is a transconductance amplifier. It's a current to amplification device that we are going to be using today because we're making Julian a mixer. Julian kind of texted me with some challenging things that kind of gripped me. What's up, Bandit? I love that emote. Julian texted me with some challenging things that I kind of I wanted to play with, and it ended up being this whole Fusion360 thing because I'm trying to make something very small, like smaller than I ever have. And so I wanted to show you guys some of the process. I've got some of the schematic down pat. I think enough that we can start looking at whether or not electronics are going to fit at all on this thing. Or if the restrictions of JLPCB and maybe the limitations of Fusion software would keep me from being able to do this. I'm not sure. Oh, fuck, I forgot to restart this computer. And then I cursed during my intro. The morality police say you can't do that. Although not restricted in any way by Autodesk. That would be just general YouTube algorithm shenanigans. But we're more than a minute into the stream, so we're currently 7 minutes. We're almost a full YouTube video into the stream. We gonna fix it today? No. No. We're doing Fusion360. We're gonna try to make a 2-space-sized module. It's actually fairly restrictive. All these modular synth kids, they're not kids. They're actually full-fledged adults, which is scary. But my buddy Julian has his setup, and his setup is portable. He's gonna bring it here on Saturday. The thing about his setup though is that it's not a lot. There's not a lot of room for a lot of modules, and to do some really cool stuff with eurorack, sometimes you need a lot of modules. And so, in order to make fully fledged sounds out of the thing that sort of are pleasing. So I have been tasked with trying to make him a module that is just mind-bogglingly small. It's a very, very small module indeed. And so we can either go horizontal circuit boards sticking out of the back of the thing, or we can try to fit this all in 50 millimeter by 100 millimeter. And we're going to do some stuff to the PCB today. Why is there a small car on the screen? It's just another project that I've been working on. It's another Fusion360 thing that we've been working on. And I broke it. I ran it into a curb trying to get a top speed of it. But this is all designed in Fusion 3. Well, this is from GrabCAD, the Lancia 087, I think. Body is from a low poly model, and then I used AutoCAD and some other stuff to kind of hollow it out and turn it into a car body. Yeah, it is a Lancia. It's the one that they made 200 of, the rear-wheel drive rally car, to adhere to Group B ruling that it has to be a consumer car. So they were like, fine, we made 200 of them. So these are like explicitly rare. And then we put it on an all-wheel drive car chassis, which is a little bit of a disrespect. Currently, my printer is not working. The printer had a gap in the separation film at the bottom of the reservoir. Oh, 37. Yeah, that's what it is. I thought it was. I am mixing it up with 187 quality rolls. Crashed it trying to get to 88. I got it to 55.2 kilometers per hour. It was 37-ish miles an hour. But the run that I did after that was faster, but I unfortunately bopped the curb. And it blew up the model. And, of course, Cluck J is there to be like, I told you that would happen. I knew it would be brittle. And I'm like, it's not supposed to survive the crash. I'm glad it blew up. And then we could just print another body for it, because that's what the liquid printers, that's the goop printer's all about. I'll be able to just spin off another body, and then we can work on, during the series of streams that I will be doing for Autodesk licensing, we can work with the mesh body here to put lights in this thing. I can actually, because I've got the magnet connections here and here, we can make it power lights. Those can power some, not high power, I'm not going to give it actual headlights, it's just going to have white LEDs on it. But it'll be pretty cool. I mean, the Lancia worked really well for the sort of wide stance of the RC car. This is kind of a wide stance for the wheels that it's got. It's neat. Only problem is it's not an all-wheel drive car. The actual real car is not all-wheel drive. I just like the cyber styling. I could do a Lancia Delta that is famously all-wheel drive, but... And I do have actually a low poly model of it that I was working on. I have to get the process down to like a few more discrete steps because I'm sort of learning it as I go. The Stancia of the Lancia. I know I'm not saying it like the Euros would say it. I'm saying it with my accent. How's everybody doing? Crystal Coder and Bandit? Nothing's working? Oh, you guys are not showing up in the social stream, Blade. What's up with that? There we go. Lancia. Yeah, I have no fucking clue. I'm just going to say Lancia in my nasally American voice. Nobody on YouTube yet. We'll get them eventually. It's cold in here. It's cold. The temperature finally broke. It's no longer summery out in the middle of October. It is dry. The dryness is dry now. There is no moisture to be found anywhere. We are in the middle of a pretty decent drought this season. And every forecast that I look at is dry. Everything's dry. It's just there's no moisture. Restart Fusion. Upload in progress. What could you possibly have been uploading during all of that? Jeez. It's trying to, it's little gremlins inside of the program are telling Autodesk exactly what I'm doing with my computer. He's got Windows open. Do we need Arduino open? We do not need Arduino open. Why do I still have Arduino open? I have not tended to this computer in a little bit. We've got all kinds of stuff that I don't need open. I do need to remember to order parts. I got to order all those chips today. And I don't think I can just go... I think I have to go through DigiKey, but to get the... well, the part for this, the voltage-controlled amplifiers for this project, I need to go through like a separate place. It's not... like, DigiKey doesn't carry them. They're that weird and custom. Lancia, oh, that's right, it is an Abarth. It's an Abarth. The Abarth did their signature giant wing on the back. They were merciful this time and didn't do the giant wing by just opening the tailgate, but the giant wing completely blocks your vision. There's no going in reverse in this thing. I think it's great. I love the styling of it. It's got one of the best front ends. Not right now, but I mean just like, you know, when it actually works. when it's not blown up and in two pieces. And then from what I was watching, it was the last rear wheel drive Group B winner. All right, all the windows open are deliberate. Yes, they are. Okay, that's a lot of windows. So the other one that we need is the... it's actually in the schematic for what we're building. Hey, what's up, Madamu? How you doing? How you doing? How you doing? This is the first sponsored stream that we're doing. Autodesk was kind enough to give me a copy of their software if every 1.5-ish months I did a stream for them. And it's not so... I'm under like literally no other obligation than to put Autodesk ad in the title. That's it. You know, we're going to use their software today. I think those are the two minimal things that I need to use their software, not even like exclusively, just you know, happen to use it, and then also be honest and put the hashtag in the title so you're not lying to people. So that's it. It's pretty cool. Julian and Dave are going to be here on Saturday, I think. You know, usually, you know, so, well, no, not usually. Sometimes something will come up last minute, so I don't want to overpromise, but I believe that they will be here on Saturday, and I guess I can catch up with them on progress with things going on around here. I know I've had my head to the ground, and I've been trying to get stuff done as much as possible. Of course, not getting anything done in the process. I don't know why things have been so frustratingly slow. but they will be here on Saturday. We are also host to some rats. We have rats in the house. Apparently the dog treats that have been broken into, my barley that I have in the back of the basement that I haven't touched in a couple years, got broken into, milk bones in the garage, and then the garage leads to a path that comes all the way over here where there is a dryer vent opening, and so they've broken into that, and so we're gonna have to have tons of stuff done because they got into the attic. They nested in the attic, so we need to get like new insulation installed and all kinds of stuff in order to keep them away. Like I said, the heat broke around here. It got cold, and so when things get cold, all the critters try to come in. And we're in the forest, so you know, Pennsylvania, Penn's Woods. So we're in the woods. There's lots of critters around. So we thought it was a squirrel. We thought it was a mouse, but mice don't chew silicon dog bone molds. We get a silicon dog bone mold for freezing treats. We're gonna make some treats with that at some point, and we forgot about it. But it was in the back of all the dog stuff, and there were bite marks. They were nibbling at that, and I don't know, eating it or just using it for nesting. They ate a part of a boot too. And this is like, it's not a low traffic area. This is in an area where we keep all of like the bags that we use for shopping and all of the dog stuff that we're constantly going into. So these guys got brave. They got very, very brave. I think they inhabited fairly recently though. I don't think it's been a long-standing thing. I use a lot of different CADs, free and paid, to be honest. Fusion is the best. Well, that's your opinion. I've never used like Altium. I've never used Altium. I've never used the super duper, you know, electronics CAD programs or even the 3D design programs. I have not kept up with that stuff. I learned AutoCAD in school, and it was a command line back then. And so I got back into it because, of course, in this environment, just doing electronics doesn't cut it. You got to do electronics, and you got to do some of the other like design stuff, and you got to make cool shit constantly. There's constant pressure to make cool stuff. But yeah, it requires a lot of like 3D design, and so I got kind of back into it. And at the time, Autodesk, I tried Inventor a little bit, and then I put it aside for a couple of years, and then I went to Fusion360 because I was like, oh, it's free and it's got a lot of cool stuff to it. So and it's the workflow that I'm used to. Easiest to work with, that just makes sense. I agree with that. I guess I agree with that. It just makes sense to me because that's what I cut my teeth on. So if I had been using FreeCAD, maybe I would have different opinions, and I'd be a little bit smellier. I'd have a little bit more reek to my armpit because I'd be in a Linux environment. True facts. Where's that fan pointed? I've got a problem with static electricity in this shop, and I've got this big moisturizer that I need to hook up again and fill with water. I didn't want it to get moldy, so I kind of cleaned it out and let it dry out. But I think I'm going to need to re-up the moisturizer because when I get out of my desk, my monitors turn off. I get up from my desk and my steel case chair. There was a big sale recently, and I bought a steel case chair. Very nice and ergonomic. Remember, racing chairs are designed to keep you in a seat during lateral force. You're not going to do that at your computer desk, so getting a racing seat is completely nonsensical. It hasn't even been crash rated. What if you get into an accident at your desk? Get a real ergonomic chair. Nothing wrong with Linux, just with the people. Oh no, they're people too. Almost, but let's not get too crazy. No, but anyway, yeah, so I've got an ergonomic chair, and it's fabric. And so I get out of it, and my giant ass rubs against this fabric and creates a lot of static electricity when it gets super dry. Apparently it gets super dry in these necks of the woods. And so I get up and my monitors turn off, and there's a bunch of little popping noises that are going on all over the chair. And that's not just the springs and foams returning to their original shape. The pops and ticks are static electricity resolving itself from body to body on the chair. I'm thinking about getting one of those little brass chains and just dangling it from the center of the chair. That's what they do for those static compliant chairs. Things other people have done is they've taken conductive thread and they've sort of surreptitiously tied little parts of the chair to each other. They'll have like a loop that goes around the piston that goes up to the backing. I'm thinking about doing stuff like that. If I get the sewing kit out, maybe I can make a couple little grounding points for the chair so that I don't get up and have it go pop, pop, pop. The other thing I can do is anti-cling spray on the seat itself, which actually is a little deodorizing, so I can spray my farts out of the chair and also keep myself from making static popping noises. I love my steel case. I have to admit, what I paid for, I hate to admit what I paid for it. It's been worth every penny. Yeah, steel case makes very good hardware, very nice chairs, but they are a corporate brand that charges a lot of money. But then again, the reason they charge a lot of money is because it prevents a lot of ergonomics lawsuits down the line. So, you know, hinging on that, if you're going to have your office workers farting into chairs for, you know, 50% of their lifespan, you might as well get one that's super ergonomic. And so it's like, all right, well, and then the other thing is offices go out of business all the time. So you could find these in like furniture resellers for pennies on the dollar. I would suggest doing that over getting a fluorescent racing seat that's been converted into a rolling chair because the manufacturer couldn't bother to say they're safe in any way. Ground your office chair. Yeah, I mean, that's I can do that with little bits of wire or conductive thread. But I can also just poop a little bit of extra moisture into the air too sometimes. I also need to set up a Node-RED node that'll turn off my fan and the lights at a certain time at night, just to either make me go to bed or just in case I go upstairs without thinking. Sometimes I forget to turn stuff off down here. Too lazy to open up like the web page. I'm tired and I don't want to untired myself. He's gonna go into that house music all night long song, isn't he? We're listening to DJ Every Day on the Twitch channel. That's the background music for today. It's not going to be recorded anywhere, but that's apparently how we got to do it now. And this is a mix by a friend of mine, but it's from like a million years ago. It's from seven years ago. Okay, we're not going to look at the date anymore. That makes me feel old. Did Fusion start up again? It did. We're good? We're good. Cool, we're ready to go. We're going to start from nothing on this. I already have a design, so we'll jump into that design and I'll just explain some of the stuff that I've been working on. There's a grounding mat. I don't want a mat because we've got hard floors in here. If I get grounding wheels, I don't know how Steelcase does it. Let's take a look. Steelcase static ground. Usually what you'll have is just they'll have like a little chain dangling from that. At least from a peripheral Google Images search, I'm not finding much. Speed rate grounding cable. What is that? It's a little grounding thing on a reel. Weird. Speed air. What is that for? Well, that's fascinating. Yeah, if I did like conductive thread or like a little conductive cable from the back of the seat all the way down to the base, I think I'd be okay, but yeah, what do you need to ground like that? Is that it's like automotive, I guess, so you don't static shock fuel? That'd be for like a race car though. Oh no, it's for other stuff. Is that a grinding wheel in the background? Why do you need, what is this? What is this crap? Well, let's look at just generic Google results. What did they say before I clicked over to images? Hold on, that's gonna dox my emails. Come on, do it. Dox the emails, do it already. It waits a certain amount of time to do it. Come on. Okay, it didn't do it. Steelcase Elite V2, love it so far, aside from one concern. After sitting on it for a while and getting up, it produces a fair amount of static electricity near the top of the backrest. This is exactly my problem. Looking more into it, it's entirely plastic, which I assume is normal. I've noticed sometimes end up shocking me or my PC. Yeah, my monitor turns off. It's so weird. Yeah, that clamp was too big for chair use. I think it's for like, something industrial where you would mount it to something and then clip it on. That's why I thought fuel delivery, because I know it's important that the fuel stuff is grounded so you don't make sparks, but I don't know what else. I don't know what would be that big. Unless it's for like welding. I have the buzz, fabric, and no static to report. I have the same issue. Nobody's tried to do anything. All right, whatever. Whatever, you just get a little bit of bare wire or some conductive thread and just kind of go to town on it. How's everybody doing? I know I've been a mile a minute, but it's been a couple days since stream has gone up, and there's been a lot of things happening around here. This is sort of the time of year when a lot of services are being scheduled on the house. So I've got people coming in for this and that and the other thing. We're basically making the entire like service industry profitable at this time of year. It's a 90s household, so all of the stuff that just like periodically needs to be done. Carpet cleaning. We did carpet cleaning already, but like, you know, getting the floors deep cleaned. We got to get new insulation in the attic because there's mice. And not mice, rats. Fucking, we have rats. We have rats. That's the scratching noises that I was hearing in the walls the other day. We've already found one dead, and it was a rat. It was not a squirrel. It was not a mouse. It was not a bird. It was a full-blown rat. Obnoxious. It's the time of year when the forest tries to sort of go inside. And then we're going to get the chimneys cleaned just in case, which I don't really think needs to be done, but I was outvoted on that one. God knows what else. There's like 70 different people. There's like a window guy coming. All this crap is just getting done now. So things are a little stressful for me for a little bit. And so to alleviate some of the stress, I have guests coming on Saturday. Even more shit to pile on, just right on top of the pile. Julian and Dave hopefully will be here with their synthesizer set up. So I got to clean that table off and make it hospitable to them. And then I have to get that mixer fully realized. This is my old mixer. I have the new mixer on the game setup because of all the gaming streams that we do. I have this expensive ass mixer over there, and I have done nothing with it for a year because we haven't done a single gaming stream. We need to go back to gaming Saturdays, so maybe this can kick it off with Julian and Dave doing a little bit of music stuff here. It should be pretty cool. We don't get a lot of viewers for that, but whatever. I'm not concerned. We're still gonna do it. And then, you know, hopefully I can spin up some game streams and get that avatar running, that VTuber avatar. I need to get that on this machine and get that up and running. That should be pretty cool. And then I'll have just the little bother in the corner for the gaming streams. But yeah, Julian and Dave on Saturday. I got to get my old mixer ready for them so that they have a sound input that's stereo. 2 sound inputs that are stereo and compatible with all their stuff. And then that can be on its own channel, so that means that'll go to YouTube as well. And I don't have to worry. This computer can still have muted audio. This computer streams to a track that is broadcast only on Twitch and only live. The VOD on YouTube and on Twitch for the limited run that it's on Twitch, but also it's going to be on YouTube longer. That doesn't get the audio. So the music that I'm playing right now, it's gone. It's only live. It's gone to the ether. Of course, I guess Twitch can still do a live takedown of a stream. They still have that ability. We know they do now. But I don't think they would do it for me. He's playing Michael Jackson. Destroy his account. Turn it into atoms. Yeah, I like this RC car. I think it's a pretty cool project. I've had a lot of fun with it. Had a lot of fun with the RC car. We're not done with it yet. Future plans. I would like to make the windows glass, get the GPS out of it, and then make the taillights and the headlights light up. Because I think that would be much cooler. And then maybe I got to learn how to paint. Atoms reassemble into oh bother stream, please. I'm not that important. Maybe I can become a more popular streamer. Oh, I gotta fix this. So I tried the protector on the 3D printer, the Goop 3D printer in the other room. And apparently, oh, by the way, that urine smell that I was smelling in the other room, that was probably actually rat urine. Probably actually urine. We got the carpets cleaned, and there was apparently a dead mouse in one of the traps back there, and then we had a dead rat in the other part of the basement. So where are these smells coming from? Not me. It's not me. And it wasn't the plastic either. The plastic masked it. It made it so that I wasn't able to hear smell. I wasn't able to detect the hear smell of a dead mouse. But yeah, we got rats in the attic. And that's not getting resolved immediately. That's getting resolved sometime late in November. The fun that we're gonna have, just so much fun. So much fun. What was the other one that was getting done? Oh, all the vents. We're getting all the vents dusted. Is that what a rat's nest in CAD is all about? Yeah, that's essentially, but yeah, that's exactly it. That's exactly it. It's what they use in order to locate an inert silicon dog treat mold and chew on it. Chew it to bits. There was just a significant portion of it was missing. We never used it with food, right? The silicon dog treat mold was, oh, we should do this sometime. And so we put it in the back of the dog bins. The bins where we keep all the dog stuff so that we keep it together. And it was chewed, it was gnawed to shit. What are they doing with inert silicon mold material? It may be somewhere in the attic. Little fluorescent red, pink pieces of inert silicon. I know, it's like chewing rubber. But yeah, mice don't do that. Rats do. Squirrels, maybe squirrels do that. We might have had a squirrel, but I don't think we had a squirrel. I guess we'll know when they clean out the attic. Basically, what they got to do is go up into the attic crawl space and replace all of the insulation, then wash everything and get it clean of all the rat piss, because the rat piss attracts more rats. They go, oh, there's rat piss and pheromones over here, man. This place is cool. Let's go there. At some point, we have to warn all the neighbors, too. We're in a forest. I mean, like, there's critters everywhere. So this is just part of the living in a nice area with trees. It's not even that nice here. Anyway, what's this doing here? Throw this out. But that's been the drama over the past couple days. I was like, should I do stream today? Like, I have to basically get my calendar out and figure out when all these people are going to be here. So there may be interruptions with future streams just because of all the crap that's being done. For the most part, the people scheduling these things have been really good about not overriding my stream, which is, you know, okay. I'm happy for that. I'm very happy for that. So we may be able to we'll probably still do just fine with all the streaming. Yeah. Well, that's life. It's life. I think the vent cleaning is happening on a Wednesday, so that won't interrupt with this stuff. It'll interrupt with my my plans to be ordering parts on those days, but other than that, I think it'll be totally fine. And I guess our dog did a terrible job of catching the rats. She's just not cut out for. She's a herding dog. She's not a mousing dog. So, oh well, we should have gotten a mousing dog. Willow has been totally adorable during this whole thing. Every time we have like a person come in to do a job, she just cozies up to them. You've never seen a dog so desperate for attention. It's like we don't feed her or pay attention to her at all. And she finds this new person as a bastion of attention and positive vibes. And she just goes up to them and is practically flirting with them the whole time they're here. It is crazy. So for some of these things, I'm going to have to keep the dog in exile down here. Maybe we'll finally get a stream where Willow is hanging out around the shop, because that's originally what she would do. She just got sick of me yelling at the furniture constantly and moving this stool. When I move this stool, it goes honk, and she hates that noise. As soon as I sit down on the stool, she leaves. She's got a whole bed set up under my desk that she loves, and she'll sleep. She will ugly snore under that desk, which I can tell you, there's nothing more motivating to doing like a pure like on paper project, like, you know, designing a circuit board and stuff like that. Nothing more motivating than a dog next to you going like every now and then. It's very, very cute, very heartwarming. I have to figure out if I want to do anything with this. It doesn't really show up on camera as much as I wanted it to. This is the Spaceman Nebula. It doesn't look quite as striking as I thought. I think mostly the upgrades that I'm going to do to the stream are the VTuber for gaming, and maybe for like a CAD day, if we've got a CAD day where I want to use the whole screen, we can try to get that VTuber model up and running. I need to do some stuff with it. I think I need to make some stuff with it, and in order to figure out what I need to make with it, I need to use it a little bit and sort of get used to using it. So I would love to get the Stream Deck XL running too, so that I have more controls at my fingertips and I'm able to, you know, get this stuff properly. And we'll have to figure out what some good games are to do. I don't know if I want to do just Satisfactory, because if I do Satisfactory, it'll never be up to my own personal requirements of cleanliness in designing stuff. I don't know how much of today is going to be taken up actually doing the CAD work, because I need to make some decisions on the schematic. And what we're doing is not all that crazy. I think we've got a pretty good idea of what we should be doing. I just need to choose how many amplifiers I'm doing on each stage of this. And part of what's going to limit that is the size of the circuit board. So when we get up to starting, it's gonna be like a ton of bricks. We're gonna jump right into the project, and I'll show you guys everything that's going on. I'm hoping that we get some people in here who know what they're talking about. If we don't, we're gonna do a lot of Googling of circuits today. But I think mostly we should be armed with all the stuff we need in order to kind of throw up a very quick sizing thing. It'll be interesting. You guys will have fun. I know you will. You have to. You are legally obligated to have fun today. Should I get started? Let me give it another minute. I just want to make sure everything's settled properly. What am I forgetting to do? We've got audio, we've got video, we have stuff on the desk, room for the mouse, dust on the keyboard, phones in the cradle, and the silver spoon. I have insulin, limited insulin. This is going to run out soon, but this one had some adhesion issues. The sticker material under this part of the pump went under, and so that's in like the perfect position. If I'm putting on a shirt, if it's missing a lot of the adhesive, it'll rip off very easily. It's got about 40 units of insulin left in it, so I think it's good until the end of stream. I think it's good through stream, and then tonight I got to do grocery shopping. Oh shit, there's so much stuff going on. I was watching a YouTube video of Elon Musk's new 100,000 GPU AI cluster. It's fucking nuts. I really wish we could stop with this AI crap sinking all of these computational resources, but the cat's not going back in that bag, is it? I saw a thing about people like don't know how to write emails anymore because of AI. It is a very interesting tool, but it seems like you can't utilize AI properly without knowing enough of what you're doing. I know Flatulent Gonad used it in a very resourceful way, having, you know, not really knowing what he was doing, because he didn't know the hardcore programming for all the screens that he utilized, and so he had ChatGPT doing a lot of that hardcore programming. But even he got so frustrated that he broke all the screens. So I don't know. Robaz is using a lot of ChatGPT in order to make his game, because he doesn't know a lot about the coding. And again, I mean, like, I don't like the gatekeeping. You know, you have to learn C++. You have to learn C#. You have to learn this programming language in order to do the thing you're doing that's not really programming, making a game. I want to make all the art of a game, and I have an idea in my head of how it's going to function. I don't want to have to learn how to code. But games are code, so it stands to reason that you would really have to learn how to code. But AI makes it so that you kind of don't, but you can't really check over the code with a fine-tooth comb, even if it's going to, you know, like it saves you a ton of time, right? You don't have to do all of the very deep level coding, but you should still go through and look for weird errors and stuff. Because if you don't know how to code, you're going to get an error. You tell the AI what the error is. Supposedly it's going to fix it. You're probably wasting a lot of your time. I don't know. It's fascinating for me to watch it from the sidelines. As somebody who would go in and want to rewrite all of their code to be completely minimalistic versus how an actual C++ programmer would go through and make something that's like a framework of things other people have done and has a lot of whistles and bells that they're not going to use, that they just disable within the blocks of code that they put together in order to make the whole ensemble. It's a different sort of approach. And then using AI where it's going to make something that's not minimalistic and is sort of a hybrid of the two, maybe. Fascinating. It's fascinating. I don't know what to think about it yet. Good time zones. Good zones to you as well. Can I get AI to make me a minimalistic wireframe model of a Lancia 37 with separable glass that's printed in a different material and headlights and taillights that's in a clear resin? Probably not. The humans are still needed. Ask Elon. About to tone out with the music? The music will go away in a minute. Is it too loud? Ask you. No, Elon has his own. He's got his own little pet AI that he's using for political purposes apparently right now. Grok. There we go. That's a weird sounding word. Let's use that one for AI. That's fine. I like it. Yeah, we're dealing with a lot of stuff right now in the household. There's a lot of stuff going down. We found mice, and not just mice, rats. I keep saying mice because it's easier and it sounds more innocent. But these little shits chewed on some winter boots. We had winter boots by the door, and they chewed on those. They chewed a hole in our rubber boots. Those are rats. He's a very strange man. That's as neutral as I think any of us could put it. Yes. That's about as neutral as any of us could put it. All right. Should we get started? I've got all that ad stuff in the title, so everybody knows what they're getting into. Let's get the music out of here. Even though I do like DJ Every Day. It's a good zone out kind of music. There's a lot of body to that. DJ Every Day is one of those ones where you start listening to them and it like builds and builds and builds and builds, and before you know it, there's just so much going on in the thing. Hey, let's stop talking about Elon Musk for 5 fucking seconds. I'm so sick and tired of hearing about these same people day in, day out. I'm in a swing voter state, so I have more pamphlets than I could possibly even wallpaper with. It's getting ridiculous. We've got a week of this stuff left, and then all the residuals slowly die out, and suddenly nobody cares about any political issues. I'm done. I voted like 2 weeks ago or something when I did the mail-in vote, and it's already been accepted into the system. So we're done. We're done here. Let me get rid of Start Soon, and let me actually talk a little bit about what's going on. The title's different today. The title is different because this is a sponsored stream. Autodesk has given me a copy of Fusion for free. Well, not free because it's quid pro quo. I have to actually talk about their software. Now, I am under contract to not be untruthful about my experience using. Ooh, I had a burp that had nothing to do with what I was talking about. I have to be truthful about my experience with the software, so I'm not going to pull any punches. And I just have to tell you guys that they gave me this for free. I don't even know if I have to disclose it in the way that I am right now. I think I just have to like put it in the title. So we're going to do a series of these every couple of months. I don't think we're going to be able to avoid the software for that long because this is the CAD software that I use anyway. And all of our projects involve 3D printing these days because, you know, it's fun to make a stupid thing and to be able to hit Control P and then it's spat out by your 3D printer, which is not in the dark. It's just that camera expects that it's under track lights. And that is my 3D printer, believe it or not. I think I bumped into the camera. Anyway, we do a lot of 3D printing here. We do a little bit of the printing. So, and electronics design, you know, as we get into modular synthesizers more and more, I'm hoping less and less. So we need to do something other than modular synthesizers, but as long as you don't have to put something like sponsored in the corner. I think the streaming platform does that for me because there's a checkbox that I have to check that says, this is sponsored content. So I don't have to do anything like that, and I don't have to sit here and do an ad read. If I was doing an ad read, I'd be doing better financially, but this is not an ad read. This is just me using the software as I normally would. And, you know, honestly, like if they think that that has intrinsic value to it, the value is priced at the cost of their software. And I'm happy with that. I think that's a mutual benefit for both of us. I think, what is that? This is like a car crash. This is not mutually beneficial. This is a bunch of stuff shattering after it's impacted itself. Hey, Gonad, I already mentioned you, by the way, during the intro. I mentioned how you smashed all of your screens in sort of my own experience of watching people use AI from the sidelines. Between you and Rob Oz, I'm curious to see exactly what's going to happen in the near future with coding, because he's using it to make a game, and you've used it to do the screens, and you end up smashing all of your screens. Rob Oz is doing something a little bit more complicated, and I'm wondering what's going to happen there. One time I used ChatGPT to take assembly instructions code from a PIC microchip and had it translate to C code. That was helpful. Interesting. Yeah, the VFDs. I still need to do stuff with mine. That's, you know, you mentioned that, and it seems like a GPT-style program would be really good for reverse engineering of software, where you take like a hex file off of a chip and you reconstruct that into loops. Having another layer of something like a language model AI might be really good. That might actually replace a friend of mine who has a 6-figure job. Ooh, that's really bad for him, actually. Wait a minute. Oh, he's in a bad position. His ass is about to get replaced by AI, isn't it? Wasted a load of Arduino, so the whole thing went in the bin. I relate to that very strongly. There's an escape of high voltage from one, and it broke everything. Oh, man. And I assume that was a big... You saw the pile that... for the latest... this should be part of the intro. Off of the latest... Bad Obsession Motorsports video, the Project Binky, the pile of Arduinos that they had, that must be like $600 in electronics equipment in that shot. I thought it was absolutely insane. But anyway, yeah, Autodesk gave me free software, hence all the disclaimers on this stream. We're going to use it today because Julian called. Julian called at the worst possible time. Julian called at a time when I was ignoring Autodesk because I didn't know what the future of my license would be. And part of the title of maybe the next one of these, it may take the form of the legally mandated Oh Bother Autodesk stream, because I was on an educational copy and my EDU, my ability to continue with the EDU has expired. And so when that license expired, they said, hey, why don't you prove that you're in academia? And I couldn't. So I could not at the time. So this is technically comeuppance for Bother, is that now I have to shill their software for my license continuation. Oh, they were out of the scrap. Yeah, so I guess if the screen eats it, it could be like hundreds of dollars for a VFD. Those aren't cheap sometimes. Yeah, they'll take a hose to me if I every 1.5 months if I don't do one of these, which is, we do this anyway, so all I have to do is a couple of hashtags. But Julian called me at a time when I didn't know what was happening with my license. You know, all the 3D design that we do here and some of the circuit board design is all done with this piece of software, and so I had lots of files, and so I was worried about it, and so I kind of was ignoring what was going on. And in my dealings with Autodesk, everything went through. I booted up the software, everything went through, and then I got a text from Julian saying, I have a specific need for a mixing module. And I said, I have a specific need for a light project that's not going to totally take up 1 billion hours of my time and that we can get done pretty quickly. Again, car crash. This is like my symbol for things meshing. And this is a car crash. This is a bunch of particles flying away from a collision. Or it's an anemone. Ooh. Anyway. Yeah, so his project is to make a eurorack compatible module that is a mixer. It's not just an attenuator, it's a mixer, and it mixes stereo signals, 2 stereo signals into 1 stereo signal. Not as easy as it looks. The 2 stereo signals are mono signals. They could be anything, or they could be left and right audio. They each need to have their own attenuation, and then the output to a headphone needs to have its own attenuation. So there's a lot more going on here than first blush into it. Now I have something like that. This is a mixing attenuator. You could do 2 of these, and then you would have your left and right. They would just be 2 separate entities. He mentioned normalization, and I have absolutely no clue how I would do any kind of left-right normalization, other than the way that, what's her name called? Synthrotech does it, which is with a potentiometer on the back of the module. You could balance left and right. With fronds like these, who needs anemones? Oh, Jesus Christ. Okay, so like, I mean, yeah, you could do 2 of these modules, and then it would be six units. Julian has a modern, portable, really nice eurorack setup that he keeps portable. That's kind of an important thing that he does, because sometimes he will use it at shows. I don't think he does it very often, but he does travel with it. He brings it over here to justify his portability of the whole rack setup. And that's why he very often breaks things. They've got another broken, I think, mixer of some kind. Something of theirs broke, and so they're bringing it over here for me to try to fix it. Another thing, things are starting to pile up. I need to actually start clocking wins on all of these things that I'm fixing. But anyway, it needs to be small, and it needs to be compact, which means it's no more depth than 35 millimeters. So we're going to try to make this a singular PCB. We might fail. And if we fail, I have to put a bunch of standoffs on the thing and make it 2. And at that point, we are pushing that 35 millimeter limit of how deep things can be. In addition to that, he wants this thing to be no more than 2 rack units. 2 units on the front panel. This is like 5. This is probably about 2. 2 is the width of the Donkey Kong connector, the often used and much replicated eurorack connector. I have like a bag of about 1 million of them, but I can't seem to reach it. I don't know where it is. It's way back there on the desk. So it needs to be about as wide as that. So in order to figure out if I could pull this off at all, because we're talking about 2 mono inputs times 2 and a stereo output. That's 5 Donkey Kong connectors and 3 knobs. 8 things. Can we even fit 8 things? This is 4 things, and it goes up to just about half of the crimes and ornamentation. That's actually a little bit less. So here we have 1, 2, 3. Oh, sorry, that was 3. And if we have a 4th thing, that goes to just about half. It seems like, given the space that these things require, it's going to be pretty tight. This is where Fusion comes into fruition here. I have been using Fusion for quite some time. I called it Fusion360. I wasn't even sure if I should call it Fusion Eagle. I don't even know if Fusion360 is a thing anymore. This is Autodesk Fusion, I guess is the title. So I've already violated all of my NDAs by making the title of this stream. But what that software allows me to do is associate good-looking 3D parts with all of my footprints for stuff. So I can get out of the keep out layer and see how compact this actual thing is. It's Fusion360 for sure. I went to their website to try to look at some of the branding guides, and I probably could have gotten a little deeper into it. I just wanted to see what the modern one was, because they might have dropped the 360 on it. Everything about the software just says Autodesk Fusion. I haven't seen a 360 anywhere on the program. So they might have dropped the 360 on it. See, Autodesk Fusion. And of course, our work group, Penn Island, is still going strong. Anywho, I started out with this weekend because I was too enticed by the project, and I meant to do this with you guys just live, but I had to find a couple parts. Putting parts into Fusion Eagle is a process. It's complicated, and they're working on it. They seem to be working on it, at least from what I've seen. So we are looking at Julian's obnoxious, where is that? I don't think it's in this one. Where did I put the actual thing? Vent tides, PSU, panel templates, mod test module. We will get back to the module tester because I absolutely still need it. Marbles, 303 kinks. Oh, Jules's absurd volume knob. You can already see by the title there that I've been completely incensed by. I'm annoyed by the project. So here I have an electronics design. It's how we kick everything off. I started with the panel, and I said, how in the hell am I going to fit all this stuff on the panel? So we started an electronics design, and at first I started with the board being flat. I thought I would put the board at a right angle to the panel, and so you'd have the panel and then a board coming off of it that way. And that can be done. I've seen a lot of modules that do that, but his specific reference was 2HP. And so if we look at what 2HP does, and all we need to do is open up their front page. Not this view, though. This view, they don't tell you what the things are. 2HP does everything in these 2 rack panel forms, right? They're very, very small. Hey, what's up, Disco House Days? How you doing? We were just listening to DJ Everyday, who does sort of, well, it's more techno than Disco House. 2HP, 2 panel modules, 2 rack spaces on a eurorack. Very restrictive. If we did side panels, if I did a PCB going at a right angle, the problem is getting that in the center of it, because the thickness of the board is actually going to mess with us in this case. I was going to have like side plug plugins, and at that point I made a 30 millimeter by 100 millimeter PCB, and I said, how in the hell am I supposed to fit a lot of electronics on it? And Rue Moore, who's another one of the electronics people that fled to Blue Sky, commented immediately, what are you talking about? There's tons of room there. Well, since he commented that, I actually took a look at 2HP, their home screen, and what kinds of stuff they build in this image right here. And I was like, oh, I see. So what they'll do is they will have an interface. Look at how many things holy crap. They will do a PCB that sits directly on all the Donkey Kongs, and they'll have surface mount right angle standoffs that go into a circuit board that you then plug power into and houses all of the rest of the electronics. And then I also saw, I looked up some two panel mixers, and I saw that Synthrotech did it all in just one singular panel. One singular panel for an entire mixer. It didn't quite do the right things, but yeah, the Donkey Kongs are these mono jacks that we use in all this stuff. I have tons of them. I had to buy tons of them. And they're not super common, even though they do have a standard part number. It's not well known. And so there's one place that sells Donkey Kong. Thonk sells Donkey Kong connectors. Those are these guys right here. Those are these guys. These square mono jacks. I have a stereo one. It's in a bin. And that's what we're going to be using on this. So I thought it would be a perfect opportunity to break out the Donkey Kongs. Girl, you ain't thick, you thonk. You thonky. She thonk. She thonk her way into my life. I remember that song. No, I don't. What am I talking about? Okay, so yeah, so this is just one method of doing this. This is a very appealing method of doing it. It means that I could put a lot of stuff on this, or I could do another circuit board on standoffs behind it. So before I do any of that, I need to know what my limitations are. I need to know what I'm able to do with the board house, what they're able to produce, and I need to set all those settings into Fusion and get all that stuff together, because I did a little bit of work. And if you'll notice, there's something very special about this image. Hold on. Something very special about this image that I discovered myself. Look at how the pins come off of the potentiometer. You can see here that the pins come off and they go woo, and they make a little water slide down to the board, right? They do this little woo, look at me, oh yeah, I'm a little three-dimensional pin. And then you'll also notice that the anchors hug the sides of the boards. They're right up there against the sides of the boards. Two little tricks in there to get everything squished in. It's coming up on 5 years since I've been in the States. Ah, hell yeah, brother. Well, I should say hell yeah, cuz. What's like the biggest adjustment from coming from Australia to the States? Like what is the biggest like thing that's just kind of weirdly different that nobody talks about? That's my big question. So they get these things pretty close to one another. How are they getting all the potentiometers in there on some of the more compact modules? Well, it turns out it turns out on the more compact ones, let me find one. I got to find one that has a bunch of stuff. That's one candidate right there. On the more compact ones, what they're doing, and it's kind of subtle. See how this one doesn't bow out as much as this one? Tipping. Tipping culture, man. I feel like, and this is something that I'm going to have to do, they're squishing those leads up against the potentiometer to get it to fit a little bit better. Yeah, I've got it. We'll see the part number in Fusion. I actually found a, I use a lot of GrabCAD, and I think I need to go through my library again and give credit to all the 3D models in the comments, because I use a lot of GrabCAD to do the 3-dimensional models. Some of the models come from the manufacturer. So, these manufacturers have brilliant 3D models for all of their electronics components. GrabCAD is where I sort of make up the difference and find GrabCAD is a very fusion-y kind of library of just tons and tons of 3D models. The creators on there are putting them up there for free. They're sharing them for free for your use. They request tips. So if I were to make money off of any of this stuff, I would send tips to these people who make the 3D models that I use. Tap and pay is everywhere here, and it's less common there. Most of the stuff here is tap and pay. I know that because I used it for a little while, and then the antenna on my credit card broke, and it no longer taps and pays, which I think is good, because I think anybody could rub my butt and get my credit card info with a nice enough piece of electronics, which is also what people call my butt. Yeah, so they're squishing those leads in, and so I had to custom make the part to squish the leads. And you can see here, the big lead coming off and going at an angle, and here it kind of goes blip immediately. It doesn't look like much of a difference, but it makes all the difference when you're putting 3 knobs and, yeah, 5 connectors. This is a 3-knob, 5-connector design. So that was one thing, and then the other one, twisting that Donkey Kong ground. Maybe just less common in this state. Backwood bogons. Yeah. I'm not going to try to do an Australian accent. Mine's so bad and it's so embarrassing. So instead of having this lead, I'll go to the microscope on this. Here's some Donkey Kong connectors in use. Get that out of the way. Whoa, this camera needs to be, hold on. Let's set up micro procedure. That's going to do the little camera trick to get the Logitech cameras working properly and sending you nice, high-quality video. What is on my thumb? Is that blood? I hope it's not something detrimental to my health, because I just licked it off of my thumb. Okay, this thing right here is a Donkey Kong connector. These things are quite useful. They're a nice little mono plug. They've got the very, very important... where's the pointing? I don't want to point with a knife today. I had a pointer earlier. Had it earlier. It was right... Where did it... Oh, my stuff is on top of it. There it is. Okay. Donkey Kong connector. Oh, we need to go back to the right scene. Hold on. You guys aren't up on screen. Donkey Kong connector. Very important part. These things are a godsend for modular synthesizers. There is a particular height to them. That would be the height of the connector as it's plugged in. You need to put a little hole in the PCB at the very end of this thing so that you get that proper click in from the audio cable that you're putting into this thing. These, very importantly, have this little shoulder right here between the square pad, the metal pad, and the threads. The ones that I hate are the, hey, what's up, Neonocat? The ones that I hate are the ones that are not pins, they're little solder tabs, and instead of this shoulder, they have just the riveted thing into plastic. And so what they do is they rivet that screw connector onto this square piece of metal that is attached to the ground pin. So what they'll do is, instead of having that extra metal over here, this will just be plastic. And so the thing screws in to a rivet section where if you screw a bolt onto the end of this thing, instead of putting all of that force right here on this shoulder, which is the same piece of metal, it puts all of that force on this sort of very shoddily riveted metal. The metal's not, super expensive, so it's very easy then to extrude your threaded piece through the rest of this thing and ruin your connector, which I've done before. So the Donkey Kongs are a very particular design. They have a certain amount of length of standoff, and they've got this shoulder here, which is probably the most important facet of the whole thing. This pin right here is a switch that disconnects when you plug in a plug, and then this one on the end here is your tip. Tip ring shield is the type, tip ring is the type that we use for mono. And so the ground is connected back here with the big ring, and then the tip gets its little click in on this little piece of bendy metal that makes sort of the switch out of the whole thing. So that's a Donkey Kong, right? When you stack Donkey Kongs, though, this little offset ground pin takes up a lot of space. So my solution for that is, first of all, pushing it in like this, and then also twisting it over to the side. So now, when I put two of them together, we can have these grounds that are sort of, twisted. So detailed in the way I never would have noticed. You don't know these things until you break some of these on somebody's expensive synthesizer, and you realize that you should have been screwing in the bolts with your hands, and then, yeah, all the little facets of the design suddenly become, they're laid bare before you. So yeah, we are making something that's going to be as dense as this right here. There's no room for any shenanigans. So I went on GrabCAD, I found a Donkey Kong connector that gave me the real part number, and then I also found these knobs, which apparently are alpha knobs. Alpha is apparently the good guitar knobs, and alpha is also the good, I guess, synthesizer knobs. So I put all that stuff together, and I made the parts, and I got it all into the point of having a 3D PCB. The way you do that in Fusion is you start with a schematic. I've stolen a lot of my parts from SparkFun back in 2014, and so that's where I got this sort of frame. You can probably find a frame part anywhere, but parts are basically it's like a tree of files or something. You have your part, and then you have the two-dimensional pad, and then you have the three-dimensional model. And so I don't know how much we're going to go through that today. Maybe I can show you guys a little bit of it, but I've got a TL072, I've got the Donkey Kongs, I've got the LEDs that I want for saturation, and then I've got the 3 potentiometers. It's going to be basically attenuation of your mix 1, mix 2, which is going to be left and right. Alps, I'm sorry, yes, Alps. Correct, sorry, not alpha. Alpha is the supplier that all music instruments manufacturers use because they're too cheap for alpha. Oh, really? Yeah, I think these are Alps models. Wait, let's check properties. Pot US is just what it's. Pot narrow bent. Never mind. I've got the part number on the 3D model. What about the connectors are, yeah, WQP PJ series. What was the part number that they put in chat? WQP518MA. Yeah, so that's the official part number. And then the stereo, there's a stereo version of it, and that's WQP-P4. So yeah, all of that stuff you kind of put down into the schematic, and I haven't connected anything yet. We don't even know what the circuit's going to look like. I'm just trying to get an idea of what I can do. Can I fit this? Can I actually design this thing within my own sort of personal parameters of how I make PCBs? I don't know, and it's not looking good. It's not looking good because when we go over to the 2D model, we only have, right now this is 9mm by 100mm, and I stop at 100mm because the $5 PCB surfaces don't go any larger than that. Right, it's 100 by 100mm for a design that costs $5. And so I've kind of placed these things at 4.5 on the grid. So these are placed at 4.5, and I got them as close as I could get them. And I did that through use of the offset pin as well as judicious use of the bent in pins. Now, keep in mind, these are just symbols that we're putting down on the silk screen. The Donkey Kongs don't even get these. These are on what's called the T-place. Well, the T-place layer is the silk screen layer, right? So T-place puts this box here. R2 is on a different component name layer. This layer will become the silk screen. So this will get printed down on the circuit board. But all these green lines, these are actually the, like, I guess they're the lines that you just use to internally figure out what the body of the component's going to be. So those lines aren't going to actually go down on the PCB itself. And you know, we see this in the circuit boards we've made previously. We can change that. We can move it to a different layer, but we don't really have to. So the Donkey Kongs are going to actually look like these guys right here. So they're just going to look like boxes with sort of a connector designation on them. But in order to fit them tight, I had to offset that pin. Now, this doesn't really give us the whole story. What is this thing going to look like? And so I decided to go the labor-intensive route of having full 3D models for everything. So what we can do is we can push all these changes to the 3D model, and we can have it actually make a 3D model of this thing, and that'll give us an idea of what we're up against. Qingpu Wensha. I don't know how to say that. Kinpu. Kinpu. I can't. There's the, like, weird pronunciations on the letters. But it's a company, yeah. They're a company that makes these jacks, and then I guess some Brits found them, and then they decided to call them Thonky Kongs. I don't know if the original supplier is too incredibly happy with that. But the company is called Thonk, and so Thonk Con. Fusion is encountering performance issues. I haven't restarted this computer in 10,000 years, so I think, you know, whatever. Deal with it. I sized these so that the pins would be over the edge. I need that millimeter because all of the keep out stuff is keeping me from placing this component. Why is there something? Oh, wait, there's a pin inside of it. Yeah. It's keeping me from placing an SO8. And so I saw, hold on, I saw when I was looking around at other designs, that's how you do it. A headphone output, which is essentially what Julian's asking for. I found a headphone output from Synthrotech. I'm not sure, is Synthrotech the one that went insane? I don't remember. It's tonal language, it's inaccessible for us to pronounce. You know, I could pronounce it if I had an example, but we're not. Okay, what is going on here? Come on, Reverb, let's go. Show me pictures of Spider-Man, let's go. Fine. No, there it was. Ah, come on. There it is. Okay. I found this Synthrotech headphone output. It has an in-L, in-R, but then it has an out L and R. So it's not what Julian needs, but it is pretty much how I would organize it. Have a knob above and then 2 plugs below each of those and then mix them for a headphone output. And if we look, they gave us this nice little side and back view, and look at what they're doing. They have SO8 chips all up in this piece. Look at how many of them there are. So I would have 2 potentiometers and then a bunch of components on the back, and the potentiometers would be there in order to balance the L and R, and then I would have to clip all the leads to be completely flush. If I'm going to fit that power connector anywhere, I'm going to have to clip the other side of the leads. Our 3D model is going to have a lot of stuff colliding with itself, but we'll get rid of that in post. We will actually be able to file down components and do stuff like that in order to get everybody to sit flush. I'm going to have to do a lot of stuff like that in order to get this to work. But if Synthrotech does it, so can I. So 9mm is not wide enough for Fusion to allow me to place this component. And that's down to the design rules of how close things are supposed to be to the edge. I can change all of those parameters. I actually elongated these pins, I believe, to be a little bit more solderable. I want to keep that, though. I want to keep those elongated pins. Yep, it's not, well, in the Synthrotech one it is. Julian wants LR, LR, individual mixes for the LRs, and then an overall output for headphones. And so I want to put a high quality headphone driver in there that'll prevent pops and stuff like that. And then I want to have a mixer set up. So I'm going to need some amplifiers on these 4, and I'm going to need them to be transconductance amplifiers because I want the 1 knob to control the 2 mixes. And then on the back, I may need to do 2 potentiometers so that you can balance how left and right are being adjusted. So those voltages need a slight adjustment on them. That's the project. It's not complicated, but it is a lot. It's a lot for us to go through. Now, we could do just like a 100 kilo ohm resistors for the whole thing. That's essentially all this thing is. This thing is a 100 kilo ohm pot and a 100 kilo ohm resistor on each input, and they go to an output that goes to a speaker. There's like not much to that, but I think we can get better attenuation and cleaner sound if we involve a little bit of advanced electronics. So let's try to get it to fit first. I need to get that extra distance off of my circuit board. I need the circuit board to be 10mm wide. I need that 0.5 millimeter on either side. It's all the world to me, in fact. So what I'm going to do is I'm going to designate an area on the side of this pin here where the circuit board is going to have a hole in it. Proteus! Proteus just subbed. Thank you, Proteus. Is there some message? What's the goal? What's the goal here? 6 months on a 2-month streak with a prime. Hey, Proteus, thank you for the prime. Really appreciate those primes. Now, we could either do this with the board outline, and I could use some of the tools in order to manipulate the board outline into place, or I could use some kind of like an elongated hole on either side of the component. If we make this very specific to board edge, and they already are because I've made the pads a little bit more narrow. That collision is something that I'm ignoring because I don't know whether or not I can use the 3D tools to turn these. These are all part of one body that's on this thing. The Thonky Kongs luckily had that ground pin as a separate part, so I was able to kind of twist them into position, as they will be on the actual components that I put in. But these, I couldn't really flatten them out. I don't know what to do about that. Maybe I could separate them from the body using this right here and then push them in, and then they would line up a little better. But they don't, we can just, since we just know that these will be modified Alps connections, modified Alpino, I don't know. We could just know that they're modified and modify them IRL. So yeah, it's gonna be a tight fit. This is literally all I can fit here. There's like fractions of millimeters between components here that I can keep in for wiggle room. The important part is all of the holes in the front are all where they should be so that I can make the front panel as well using this 3D model later. But right now, I want to see if it's even possible. Oh, and I did fit clipping detection LEDs. They'll have to be just holes in the front panel that'll weirdly illuminate from far away. I've been busy, yeah. Well, the thing is, this is not that much work. This is not an incredible amount of work. Most of the work that I've done in CAD recently, over the past couple weeks, is going through all of my designs and getting all the SparkFun weirdness out of my old files. My files, the library is called Jesse 2018, and it is a redux of my 2004 CAD. Well, no, 2007 and 8, I think, is when I was using it very heavily. 2007, 8, 9, 10. I was doing a lot of stuff in CAD. We didn't have 3D models back then. Our computers sucked, and the software didn't exist. And so the thing that I've been doing in current year, way after the fact that I made these libraries, is getting out all of the nonsense and then getting 3D models that are associated with all of my parts. It's a lot of work. I've been going through that very extensively. If you start from nothing, if you start from like not having these libraries, you're in a pretty good position because you can say, you know, I want 3D models on all these parts no matter what. And you can make all of your individual, you know, pads, parts. You don't necessarily need to make the pads and parts. You can get them online. But most of the time some of the time it's a lot easier just to make them yourself. And you make them yourself, you can then use Fusion to associate that with a 3D model. You can get the model either from the manufacturer or from GrabCAD. And then when it comes to a project like this, your friend calls you on your phone and says, I need a doodad. And you go, oh, let me see if I can make that. And so I can just throw these parts onto a virtual PCB and see whether or not I'm capable of making something like this. Certainly, if I did it with like breadboard, I might be able to get away with this. I would have to make a lot of weird custom holes in order to get everything to fit. So this is maybe not a breadboard project. And if we're going to make it a digital, well, an analog headphone amplifier circuit, we're going to need a lot of op amps. And so we're going to have to make a PCB in order to build this. But I was able to throw this together with relative ease because I had done all that work previously. So let's expand this out to 10 millimeters. This is going to be kind of painful, but it's got to be done. So let's get this part out of here. This is our SO8 that we have to fit in. As soon as I touch anything, it tells me that the documents are out of sync. That's going to happen. That's called designing something. So, but let's move this line, right click it, 9 millimeter, 9 millimeter. We're going to go 1010 on it. Look at all this space we suddenly have. Dear God. Now, can I select every single part? I don't think it's going to let me change. I could use the align tool. Oh, here we go. Oh, but that just says R1. I don't know if this will do it. We go to 5mm. Now it only did the one. So I mean, with Eagle, the way that you're supposed to do this kind of stuff is you go into the change tool, which would probably be in. No, that's going to be in design. So layers, board shape, place, route, blah, 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 blah. Modify. You go to the change tool. It's a little gear. It's on the C key. You're a 10-10. 10 out of 10 is 0. Or 1. It's 1. I'm a 1. Oh, no. Okay, so we're going to change the... Oh, God, where is it? Position... So 3D model, align, attribute set, cap, no cap, class, diameter, display, deline, the type, the unit? No. Is it not on here? Yeah, I think position would be somewhere, but thermals, thermal width via width. Yeah, not diameter. And the align is more of a text thing. Interesting. So I guess I can't really... I can change a lot of other advanced stuff, but I can't change the position that way. All right, fine. We'll just right-click on them. Properties, and we'll just hit the 5 key a whole bunch. Properties, properties, properties. Got to center everything, and then we'll see whether or not I can get the IC to actually go in. I'm probably going to have to do a lot of custom stuff in order to get that to work. What happened there? When we click on stuff, we're looking for that little crosshatch, the little crosshair on the part that's designated as its position. And one of the edits that I made was to try to get that crosshair to be the thing that I'm aligning, which in this case is the thing that goes through the hole. This one won't move because the resistor is getting in the way. One thing that they added to Fusion, to Eagle, I think in the later stages of Eagle, was the rules that you put forward will limit your ability to place things. So if something is in the way, it will not allow you to move it fully. It'll keep you from overlapping parts against your own rules. So that's what I'm running into right now. I've got to move these things sort of in order for them to actually move over. And I guess, yeah, that happened down here too. You can't multi-select? I tried. There's a way to do it. I just don't know it. I think there's a way to change multiple things at once. The change tool makes it so that you can click on something and it'll change sort of those intrinsic properties. But I didn't find position in the change tool, so. This is a piece of software that's made by a bunch of electrical engineers. It leaves a little bit to be desired in a lot of different places. And Eagle's a fairly old piece of software. I used to have a pro copy of it that was provided to me by a client. But nowadays, everything's a subscription. And so Autodesk bought Eagle, and then they bought me. And that's why we're doing a sponsored stream. Okay, so now everything's moved over to the side. It's not that many things, but... Wow, what are you saying about electrical engineers? I know what I said. I don't need to repeat myself. So this will now fit there. Will it fit down here? This is kind of asking a lot. Okay, so we need to change that this is like a keep out. Because I think we're going to have to put a part over the hole. I think we're going to have to do that. I don't have a lot of room. This is basically on the underside of the board. So if I make this into 5mm, oh, this is at 5mm. Okay. Well, then why isn't this at 5mm? This is, wait, 5.284. You lied to me. There. So that's at 5mm. Everybody's at 5mm. Everybody's happy and in the middle of the board. In Australia, an electrician is called a Sparky. I thought they were called that over here too. I learned that recently. That was not something that I knew like a couple weeks ago. There was a YouTube channel that I followed that was a Sparky. It takes a minute to render it. It's putting it together right now. It would be awesome if this was like live, if it did all this stuff live, but they have to make it their own way. Okay, so what happens here is now we have clipping from the end pins, which could be resolved by bending things, but we're going to put a little notch at the circuit board there, and we have our IC, and it looks like we've got a little bit of room. Now, it all depends on the rules of who's going to manufacture this board. Since these, can you imagine if there were mods in your CAD? Well, actually, there are mods. There's a whole marketplace of applications for this stuff. So I'm wondering what kind of stuff I can get into. What I would like is if somebody made a Topor router for Fusion. Topor is a specific product, and it routes things as the crow flies. This is great for like RF, if you're trying to like min-max your RF stuff. Some telecom stuff is used Topor, but this is also really good if you want to just make the brain veins stand out from your electrical engineering friends. You say, I use an auto router on it, and it looks like this. Oh, it hurts us. It burns, it burns. So, Synthro-Tech. Let me open this window image so I can get real close. Let's get real close. Let's go real up and close with this thing. Now, these Thonky Kong connectors, you can see here that they're bending this to within an inch of its life. They're bending it in as much as they can. The footprint is practically underneath the connector. Now, we've managed to get everything to fit on the front panel, and that was by offsetting those grounds. So everything fits, but how are they doing these ICs? Because this stuff is through-hole. It's got to have pins that stick through. It looks like what Synthro-Tech is doing. They have made a much more compact square pad, and we'll do that in a minute. We'll make a much more compact square pad, and then they are putting an IC over the hole. That's over the hole. How are they getting pins in and out of, how are they getting signal traces in and out of that? Oh my God, there's so much restriction that we need to deal with here. Luckily, all the parts on this are custom compact parts. I duplicated parts. So let's get into the parts and let's do some of these little corrections here and see what we can kind of muster up in order to get things running. Now, I did offset, so I think I want to keep the offset. I don't want to do the square pads, but the square pads let you get closer to the edge. Half of the stream you're talking alien to me. I mean, these are things that like somebody who's designed a circuit board might know about. Hopefully it's relatively accessible language. I do know I speak crazy. I speak crazy talk during these streams, but this is all part of my inner monologue when I'm putting together a design. And yeah, it's how it is. It's how it all works. The other thing that we could do is use what these things are. These are standoffs, and they're using surface mount. They're not using surface mount standoffs. That ain't no surface mount. How in the hell are they? Man, this Synthro-Tech design is like maddening to me. I can't believe all the stuff that they've done in order to make this thing so compact. We're not going to copy Synthro-Tech though. We're just going to take some pointers from them. And we need to modify some of the keep out areas that we've got on the parts that we have. So let's get into the parts. We can edit the parts and then have those edits propagate through our design. So back to Fusion. There's our part. Look at that thing. Beautiful. Oh no, I think there's a dog party going on upstairs. The neighbor has 2 corgis and we have 1 corgi. And so all of the corgis are probably playing. I hear a lot of paw noises upstairs. Because these pads are actually going to get in the way of our design. Look at that. How frustrating. You got all the smart genes. I got all of the escape dramatic people by falling into my own world of electronics and design genes. I got the modify your toys in order to make them more cooler genes, which is why we do stuff that interests me and I can't seem to get a job. Anyway, back to this. How do we make this more compact? I mean, this is all pretty compact in my own way. If we keep them like this, I guess that's okay. I could make these pads more narrow, but to what end? do I need to make them more now? I think so, because otherwise I'm not really going to be able to fit an IC between these. And then I'm going to need to make this drill hole not keep me away. I just need to get closer to this drill hole for me. Okay, so we need to go into the two-dimensional pad. If we go to the two-dimensional layout, I can go into this, right-click it, and can I actually edit it from here? I don't think I can. Edit footprint, edit component. I would prefer to go into the component because I don't just want to edit the footprint immediately. I want to look at the whole thing. And so here we have in our library, right now it opened up my Jesse 2018 mechanical managed. So I called this a mechanical part. I guess that's okay. It's a plug. It would be a specific connector. I should probably move it into specific connectors, but this is just where it is right now. We're going to edit it right here. So there's 3 facets to this part. Well, 4 if you're really counting. One of them is all of the different footprints that we have for these parts. So these have different drill holes and they have different pin spacing. You can see them kind of moving in on that two-dimensional pad. So we have the tree of stuff, which is the component. In that tree of component, we have the symbol. So the symbol is going to dictate how many pins this component has and what the symbol just does what those pins are, right? How much storage does your PC have? This is technically stored on the on the cloud, which is a bit concerning to me. I have exported all this stuff to actual files on my computer, but the Fusion likes you to use a cloud. So my libraries are actually backed up on a website called library.io, and there's a folder in my administrative folders. Where's that? Admin is all the way up here, admin project. And I've got my managed libraries in a folder, managed Eagle libraries. So that's where all of this stuff is stored. This is stored on the cloud. The only problem with this whole 3D design thing is it makes a lot of mess. There's a couple different things that it creates. Like you import the 3D part model, but then you put that part model onto a separate file that has the pads labeled out. It basically takes the pads from the two-dimensional drawing here and it puts them into the three-dimensional diagram where you can pull in, your 3D part, but then this makes a separate file. So I have tons of these files of parts on pads, and it's especially frustrating for things like pin headers where you have repeating structures, just hundreds of files of repeating structures like this. It's not very efficient. It's nice for when, on the front end it looks great, but the back end is a big spider web of BS. So yeah, it makes a lot of parts model waste that I try to contain. But yeah, so the facets that we have the part which has under it or in it or whatever a two-dimensional drawing. Then the two-dimensional drawing has footprints associated with it, and then each footprint individually has a 3D model that's associated with a footprint. But these are all just directories of files. You need to associate them with each other, and so that's what the component does. The component associates your where is that? Footprint 3D model and your your footprint, which is associated with a 3D model, which has associated, each have pins that you then connect. So you have to use the little connect diagram over here. It's a whole thing. When you get to know the process, it gets a lot easier. But what we're doing right now is we're not editing the footprint, we're not editing the 3D, the 2D model, the schematic symbol. We're editing the 2D footprint and in turn the 3D footprint as well. I managed to get through some of that. So I've got these offset pin ones that I've been editing. These I actually got from Mutable Instruments files. Mutable Instruments has all the stuff backed up online, and so they've got the variants of more and more compact designs. I think we took this design and we made the one we've got now. Yeah, so this is the one that we're going to use. I've got a little bit of extra space in here. This is moved in just a little bit, and then I offset the pin in order to be nice to us. But we need to get into this 2D model, and we need to edit that. So that one is, oh God, I've got to find it on the tree. Offset, that's this one. And how do I do this? Double click on it maybe? Yeah, there we go. Okay, so there is something here that's keeping us out of this area. all of these lines are on individual layers. It's like Photoshop where you've got a ton of layers, but there's standardization to what the layers are. And so each of these layers tells the CAD program something unique, either the CAD program or the manufacturer. In this case, we've got sort of a diagram of what the headphone plug looks like in all these useless circles here. But then we also have this circle in the middle that has sort of a crosshatch going on. So what is that crosshatch? What layer is that on? We can look through here and we can find there's like thousands of layers and they're all very confusing. We're looking for whatever one that grid is on. Well, I could just go to the properties of it. One of them is going to be a drill hole, and the other, see, there's the drill. We just looked at the little circle with the X through the middle. That one is the drill. So that's telling the manufacturer where they are supposed to drill out the base PCB. But we need to click on the other thing in here. Can I control click? Or alt right click? No. Shift right click? No. All right, somehow we need to select specifically the thing we're looking for. I guess I've got to just do it with the layers. I could do the view layer, display layers over here, and we can look through and see which one goes away. So top stop. Well, there is a T-stop there. Let's unview that. There's still another cross line there. We're looking for one that's going... I don't think it's a bottom finished layer. Well, B-stop would be... Aha! So T-stop and B-stop are where these two layers are. So they're telling us that we can't put something on the top layer in that position. That's fine, but the bottom one is the one that we really want to eliminate. So I'm going to unview the top one. I'm going to click on B-stop and activate it as the layer that I'm working on. Click on that crosshatch and hit delete. Ta-da! You really think you did something here today. Well, that got rid of both of them. Wait a minute. Let's bring that back. Bottom stop layer, click on that. It just moves the whole thing. Oh, it's part of the hole. So there is a place diagram, and if I place something like a hole, I have all these properties for it. Well, this one gives me the drill for it. And I guess giving it that drill puts it in a top and bottom stop. Drill 0.9, position there, not locked. That's all I get for the hole dialog. That means that I can't, so I can either have a hole or, because that'll delete the actual hole. So this is where I have to Google, because I thought we would be able to just get rid of the stop layer. Let's see, I'm just going to do Fusion360. Hole stop one layer. Cut holes, cover a hole, lock apart place, holes through single body. No. Avoiding a hole in parallel. Oh, this is going to be tough. Fusion Eagle. Maybe not 360. Hole in a footprint, not use the hole function. Every layer explained. Why holes have stop layer traces. That's for traces, though. I'm looking for, like, the component won't let me put it in. Maybe the component won't let me put it in for other reasons. Stop mask. An eagle, it'll automatically appear as a solder mask over a regular hole. This is the old, this is from 13 years ago. Yeah, this is not current advice. All right, hold on. We're getting misled here. So that would mean that something else is preventing me from placing the component. It's probably the closeness of, if I can, alt spacing maybe? Ah, come on. What's going on? Do I hear a dog whine? Hold on a sec. I got to go investigate. I think there might be a dog down here. There might be a puppy dog. You get kicked out? Well, come here. Come on, come here. Come on, Bubby. She's at the top of the stairs. I think she got sequestered. You want to treat? Come here. Come on. Well, come. Come on, Bubby. Everybody wants to say hi to you. Come on, puppy. Willow, come. Willow, come here. Come here, puppy. I'm trying to coax my dog downstairs. There she is. Come here, pup. Willow, what's this? Actually, don't have anything for you, unfortunately. Wait, do I have any treats over here? Where's that dog? What are you doing, Bubs? No, she doesn't want anything to do with us. She doesn't like it when I stream. She's at the top of the stairs. I was gonna show you guys the dog, but she's not participating. Can you come here, puppy? Nah, she won't listen to me. You know, it's fun to have the dog on stream, but she really doesn't like to. Maybe Will's part cat. You need to go piss, piss, piss. No, she doesn't respond to that. Well, actually, she. You know, I don't know. Yeah, I don't have cookies to give her. Willow, Willow. What you doing, buddy? Is she even up here anymore? Willow, come here. Come right here. Come on, Bubby. There's a service person here, so she's at the top of the stairs listening to the door intently and will not come down because she hears them doing stuff. Ah, that's unfortunate. I don't like streaming either. Okay, so understandably, she is averse to streaming. If we run into too many brick walls with this thing, we could work on the power supply front panel and getting some current meters on it. But right now, the struggle that we're having is that when I drill a hole through the board, that puts a keep out layer on the top and the bottom of the board, and I think that doesn't quite mesh with the amount of space that we have inside of this chip. I was going to try to have the chip straddle the connector, which I think is totally reasonable because the Donkey Kong connector requests that you put a hole through the board so that the tip of the tip ring shield plug can fit fully within the amount of space that they give you. They're kind of min-maxing by having you put a hole here, but it doesn't need the tip to stick out of this hole at all. It just needs it to go into this space right here. So it's perfectly cromulent for us to put a chip directly on top of this hole, which would be really convenient for me because my audio signal is coming in right here. We got ground like here. Audio signal is actually coming in right here. Because then I would have space here for a chip, and then I would also have space here for a chip. Now, I don't know what Synthrotech is doing. They might not even put the hole there. She won't go on camera unless there's catering. Yeah, but she needs to keep her health benefits going, so she probably should star in something. I really would like to get her on camera, though. She's very, very cute. But right now, her whole world is rocked by the fact that she was tossed onto the basement stairs and the door was closed. She doesn't even challenge barriers. She'll go up to a door and whine and look for somebody to open the door for her, even if it's open a crack. If it's open a crack and she can't quite fit through, or she's not confident in fitting through, she will not push on the door at all. I have had to push her butt through a door. But I would like her down here because it's fun. Willow, come on, come over here. You want a treat? That's a lie. I don't actually have treats. No, she's not moving. She's staying up at the top of the stairs. Apparently, the service person is more cool than I am, and so she's got to go visit them. Here, let's take a look at this IRL. Let's see what we're up against here. So here I have a Donkey Kong connector. And I have my brown cable. This one carries the brown note really well. So we plug it in. This needs to be brighter and further away. Faster, more energy. There's dust on this. This tells you the state of projects around here. This is a nice design. This is one that I built off of a Hajiwo design that uses a RP2040 in order to do a Sallen key filter and produce audio on the output. But yeah, Donkey Kong, big mono plug into there, clicks. And look at that. It barely even sticks through. I don't think I would even be able to detect that. So I would like a little bit of space under there in order to put my chip. Although I think that maybe that hole is wide. Willow, you're not allowed to whine pathetically. I'm right here. Jeez. Trapped by open glass doors, dog. I've had a few of those types of dogs in my life. Yeah, I don't understand why she doesn't just push up against stuff, but she desperately wants to be part of the action upstairs. I don't know. I think it's the guy cleaning the fireplace today. Oh my goodness, Willow. If you're gonna whine, be on camera. Come on, I need those sympathy subs. the Free Willow campaign. Oh my god, she's being so pathetic right now. I just hear whining. So the thing about this software is that it will not allow me, unless I tell it to, it will not allow me to put this at 5mm. It did, but it bumped it up. It got it out of the way. I guess it's willing to cover over one but not the other. So it doesn't like the width of this hole. The width of this hole gets too close to the pins, and it looks like it collides. What's the width of that? That's the wrong part. We've got it open in the editor over here. I know, she's so, I can hear this. It's so pathetic. 2.2mm. What's the width of the chip itself? We'll just go off of the Fusion tools here. Where's that chip? There it is. So this isn't the width of the pads, but I don't want to have to edit my... I extended these pads out a little bit on these parts so that they were solderable. What's up, Lawn Dog? I hope the illustration for the feed-through of the legs of the IC is accurate. Does look like good lead length for soldering. Yeah, it is. It's very accurate. Maybe the restrictions for the thickness of the overall board. I don't think that's it. No. Hold on, let's just say with this width right here, just inspect it. .4. This is 2.2. All right, what about the length from, hold on a sec, from here to here? 3mm. So, I mean, it's got to have like a radius keep out on it too. Yeah, I don't want to edit the SO8 part. I don't want to edit that. I want that to retain all of its properties. And actually, if it's fitting around this but not the other one, I wonder. Oh, but while we're here, we could also change these into minimalistic square pads. Can we actually narrow that pad? Shape square, drill 1.106, thermal solder mask. First... slot? Oh, it's terrible. Not slot. Do we have like octagon long offset? I don't think that. Ugh. 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 Oh, it's hideous. Yeah, square round octagon. It doesn't look like our CAD has the ability to do that narrowed square pad. Maybe slot does. Let's check the properties of slot. Yeah, there's a length associated with the okay, so what I could do is turn them into slots and have sort of, I don't, that's not a good idea. I could make them much smaller and do slots. Pad length for the IC. For more durability for soldering and desoldering components. I mean, the length is a little bit much on the pads that I have. They don't need to go fully under the IC like that. I could have them come out a little bit from there. I did this mostly for convenience in my own soldering, but if I do narrow them, I could push them out a little bit more, and that would give me a little bit more space to fit an IC like this. I don't want to have to do that, though. I don't want to edit my parts. I already edited my parts. They were symmetrical. I want to coax the dog to come down here, but she doesn't seem to be in for it. I'm going to go grab her. I'm going to go pick her up and bring her down here. Hold on. She was vaporized. There's no dog up there anymore. Yeah, she got vaporized. Turned into a vapor. Blasted her. She's gone. She got let upstairs. Okay. No, it's not the smallest IC footprint I can use. We can make a variant on the IC and we can narrow those pins down a little bit. Let's do that. So I've got variants on all my other ICs, and I don't want to blast away this drill hole because apparently it's necessary for the feel of the Funky Kong. I guess if there was a larger hole, I don't know what a larger hole would do for me. These are the questions that you ask yourself when doing CAD. Where did you get a vaporized dog emote? Where'd you get that? How do you have that as an emote? What kind of a platform is this? Shad Roch's channel. Artist. Zetsubera. Oh, you can set artists on the emotes? I gotta set the one that Pixie, or the one that hold on. Ideas will come later. Hold on. Marbles. Oh, Marbles is over here. Marbles is over here. We were using Marbleps to help test modules. Where did Marbleps go? Is Marbleps sitting by the synth? No, it's gone. It's somewhere else. All right, I don't know where Marbles is. Fairly expensive module. Spent about $75 of my own money on that thing, and now I don't know where it is. Where are you, Marbles? I'm losing I've lost my marbles. There we go. I said it. He said the line. He said it. He said it. He said he lost his marbles on screen. You heard it first here, folks. Ow. Marbles hurts to pick up. I need to shave the leads down a little bit. Oh my God, you didn't have to put all of them on there. It's all the corgi emotes. Yeah, I gotta make a couple more corgi emotes. Distant Cacophony did a lot of emotes for Tomato, and she found my channel, and she did the kitty with a knife emote because we were talking about it in Discord. I said, I need to make a knife emote, and she ended up making it, and it's very cute. But I should give her credit in the emote thing, the emote dialogue. All right, so all of my part footprints come from Mutable Instruments. Mutable Instruments has made some absolutely brilliant models, designs, and all of our designs are in AutoCAD. And so that means that when you download those files, you can load them up into your files, and you can steal their footprints, which is amazing. Burner Phone says, mind you, I have never done this, but I've been trying to learn. Thanks for the streaming this. Hey, look, don't thank me. Thank the good people at AutoCAD Fusion360, brought to you by, no, stupid motion detector. I stream in a basement, and when I'm home alone, I need to have some kind of an ability to make sure that I'm not getting robbed. So I've set the stupid cameras that we have to do a little emote on the lady who shall not be named, and it goes, motion detected at the front door. And now my dog, if you say that in front of my dog, you say, hey, Willow, motion detected at the front door. She goes, and starts going nuts, just from fucking Pavlovian response. No, listen, the reason that I'm doing this stream, first of all, is because I've got like a cool project that I can sink my teeth into. Second is because in order to do stuff like this, I use this software anyway. Third is because I was contacted and accepted into a program that gives me free full version of the software. Now, the free version of this software exists. It has some limitations to it. I think if you start with it, you won't have as many growing pains. I've got like 10,000 projects in the non-free version that I was, I guess, for a little bit of stealing. But anyway, as a comeuppance, I get to do 1 or 2 streams every couple months, and then they will give me a free version of the software. That's the transaction. So keep that in mind. Keep that in mind, just because I have influence. So you're directly saying, thank you for teaching how to do this software stuff. So AutoCAD's sitting there behind their console going, yes! But yeah, it's cool that people can actually learn from this, because I think this is a great piece of software. It looks really good. It's frustrating. Any CAD will frustrate you. So far, the performance has been perfectly fine on any machine that I put it on, but I'm a gamer, so most of my old equipment is actually fairly high quality. But yeah, this is all sponsored by them, the mixer that we're making. But it's also sort of a way that we can explore the software and get our things done and hopefully get good designs quickly. That was a really nice click to it, whereas these don't. No, they do. These click. So then compare that to one where I haven't put a hole in the back of the circuit board. These Thonky Kongs are directly on perforated prototyping board. It still clicks in, but I think maybe what it does is it makes contact with the board on the other side. Could we just get rid of the hole? I do lots of DSPs, so my machines are pretty stout. That's nice. This has a 1080 FTW in it, which is, I think, maybe overkill for AutoCAD, and it's water cooled. So the connector is going to click anyway. Do we even need the hole there? I mean, getting rid of the hole would be one way to go about it. Editing the pins to make it a more minimalistic footprint would also be another way to do it. And then we'd have to make, we'd have to associate the 3D model and everything. Manual hole placement. Not going to do that. I guess I want to have the hole there. What about WQP? Oh, wait, I've downloaded oh, that's on the other machine, actually. WS, WinSCP, Wireshark. No, I think the Thonky Kongs were on the other machine. Teensy Tides, Timer Helper, Twitch IRC. Let's go, I think, okay, so we can get from Thonk, I believe they have their data sheet for the Thonky Kong connector. Manual drill with a drill. The amount of precision that I can actually bring to the table in terms of drilling my own holes, it's terrible. It's just not worth it. You don't want that. I don't want that. Donkey Kong. Their dimensions. Those are given the square pads too. Where do they specify the hole? They're not even specifying a hole. What's the difference between the new? Old one doesn't have the shoulder. You see that? New one has the shoulder. That shoulder is really important. That's a very important piece of design. They're not even showing the hole on this. So if we get rid of that hole, maybe the hole's for the generic ones. I saw it specified in documentation, but here they're not talking about it. Funky Kong hole. Listen, don't search something with hole after it on the internet. PCB hole. Due to the low profile of the Funky Kong jacket, is advisable as a precaution to drill a 3mm hole in the PCB. Alternatively, leaving a void in the ground plane or not routing traces through this area would suffice. Aha. So it's barely a thing. So let's minimize it then. Let's not do a hole. We have no holes allowed. The properties are that on this hole, we have a 2.2mm drill, and then it gives us no other ability or information on what's going on there. So let's go to the layer, and we'll go to the T-stop layer, not the B-stop layer. We're going to go to the T-stop layer, and we're going to draw a circle. We can do any number of different things here, names, pads, lines, texts. We are just going to draw a circle. And I don't know what that distance is. We'll just take a look at it and just sort of ballpark it. Radius 1.1. What? That's a 2.2 when I looked at it. Oh, radius versus diameter? So it'd be 1.1 would be the... That doesn't look right. Well, the drill was 2.2, and then there was an additional keep out on it. And this is a 1.2. So there's no way that I'm figuring that out. Can I do like a filled circle or something? Okay, you know what? Place, draw, circle. We'll just do this. Done. Properties. So I can't fill it in if I make my width 2.2 and then take it in. I can't take it in. Draw, circle. Whoa, why is it doing that? Oh, because that's the, right, that's the, my line width is huge. 1.1. There, we can just do it like that. There, so that's our top keep out. So that's it, that's all we need. I could even make it a little wider than that, but I don't think I need to. If I run traces in there, I may need to run traces in there because this thing's so compact. All right, so now our top stop layer has just that circle on it. That's gonna completely minimize the connector. So this is a fully minimized Donkey Kong. I could probably pull this in a little bit, but I'm just gonna leave it where it is for now. So this is our modification, and since this is already the minimalistic one, I'm just gonna hit save on it, and we'll see if that will allow us to now place a component in the middle here on the other side of the board, because there's nothing on the other side of the board now. So now it should be, well, okay, so we saved that, but we haven't fully gotten out of this yet. What we need to do is push this library to the cloud. Now, have we gotten, I don't know if we've gotten it from, hey, what's up? Who's this? Who this? Code Rush, raiding with a party of 30. Code Rush, thank you for raiding consistently throughout the, all this time streaming. Party of 30, that's a lot of people. Hey, I don't know if I need to disclose this to raiders, but I'm actually supported here. This is an advertisement for AutoCAD. We're going through this design and we're trying to rapidly make a mixer as small as we can within 2 standard width. It's basically 2 panels of a eurorack module. So we're seeing if we can make the smallest circuit board we can that does what we need it to do, right? AutoCAD is sponsoring my copy of their software. So I need to declare that to everybody humanly possible. Hey, they bought me a copy of the software for like hundreds of dollars. They went to the AutoCAD store with like a big sack of money. It's actually in like a burlap sack with a big $ sign on the side, so you know what it is. And they plopped it down on the desk, and then CD-ROMs were pushed to the other side of the desk, and they slipped it to me at a bus station bathroom. And so I've got it here, and it's installed, and my account is fully funded. And this is comeuppance for me using an educational version of the software for so long. After my EDU copy expired, they finally asked for, they were like, hey, do you have any credentials? And I said, you got me, please don't hurt me. And they're like, this time. Anyway, so we're using the circuit board facet of this software. I use AutoCAD. I use it and I actually kind of like it. I've used it for quite some time. And I would be using it anyway. So what we're doing here is we're working on a Donkey Kong connector, which is a rebranded Chinese brand of audio connector. And it's got particular dimensions and it's got particular properties, but Thonk bought these things and called them Donkey Kongs, and they've been used in eurorack modules for quite some time. They're actually quite nice. They basically just have the same standoff as other panel mount electronics. So if you use them with Alps potentiometers and you use them with particular, the common rocker switches that you can find just about everywhere, and you use these what are they called? These are called tactile buttons. Tactile buttons with a particular amount of space off, you can just throw a panel on the front of this thing and everybody's nice and even. So that's what the Donkey Kong, that's where the Donkey Kong kind of comes in. It's a nice little eurorack connector. What we're trying to do is fit all of our stuff in basically a fraction of this width. Alpine. The circuit's gone to the dogs. Oh, I see. I see what you're saying. It's Alpo. It's like the dog stuff brand. So anyway, we're trying to minimize this connector. There's a couple things we can do. Now we're not done. What we did is instead of having a hole through the PCB, we did a top keep out layer that was the same diameter as the hole is supposed to be. So now we don't even need a drill on that. All we need to do is just make sure that we don't put a ground plane in that space. And that frees up our back layer to only have the pads on it. Now, the pads on that we see from Synthrotech, because, you know, monkey see, monkey do. I can't help but copy all of these clever things that would get me in trouble from other makers. This is blatant plagiarism. What they've done is they were able to use a rectangular hole in order to locate all of their connectors. Now, what we can do is we can use a rounded slot and we can make a minimal surround for that pin. So the advice from Thonk. Oh, I shouldn't have closed all those windows, huh? Well, actually, we still have this one open. Oh my God, there's motion is being detected because somebody has one of those vacuum vans upstairs. They're cleaning the fireplace flue just so that we don't. I don't know why we're doing it. Honestly, I don't think we need it done. I think cleaning the fireplace is kind of a pointless thing, but we're having it done, and that means that there's probably a vacuum hose coming through the front door. So at the maximum amount of repeat alert, I get motion detected again, and then the dog going because she heard the thing say motion detected at the front door. Oh my God, it's a mess. It's that time of the year when people in this household freak out about getting all this stuff done. So we need a minimal amount of slot through where this pin is going to be located. We have our own custom locations because the Thonky Kong connector has this flying lead, and so we've kind of scooched the flying lead away a little bit. What were you guys working on at Code Rush? Anything cool? No, just nothing cool. You guys just weren't doing anything cool. Let's see how it is. So we've moved our flying lead. We need to make just like an oval, basically an oval around this thing that is minimal, but not hyper minimal. I don't want it to be super maxed out minimal. I want it to be, give it a little bit of room, maybe not much. So we need to actually look at, we're not doing Seed Studio. We're going to use JLPCB. I am not sponsored by JLPCB. I'm not sponsored by Seed Studio. I do prefer, what is this? Okay. PCB prototype. I'm going to try JLPCB just because they have got very cheap prices on their orange circuit boards, the orange flexiboards, that I'm thinking about doing a keyboard project with in the near future. So we're going to take a look at that. We're going to try a 2 or 4 layer board. Now, apparently the 2 or 4 layer boards are very reasonably priced. So 2-layer board, FR4, $2. And then if I have to, if this gets crazy, I go to 4 layers and it's $7. Insane. I think JLPCB's silk screen is a little bit fuzzy for me, but I may have been violating their silk screen size rules. Or was that Seed Studio that has the fuzzy one? Yeah, having the price way less than shipping. Seed Studio does the $5 100 by 100, and I like their quality quite a bit, but I think JL compares to them, and they're not shipping from China, I don't think. Are they? I don't remember. So we're going to give JLPCB another try on this one. But these are the results with all these CAD files that I have with Seed Studio. It's very nice. And we can get purple. FR4 Hazel, 1 ounce of copper, inner copper weight 0.5, via covering, plugged, minimum via hole standard, 0.3. Huh. So, 0.3, so our Thonky Kong hole, oh no, it was 2.2. It was 2.2. So we're going to be well within the specifications here. JL's also shipping from China. Okay. They've got a turnaround that's surprising as hell. They probably have more business. Have you ever created layer before? Have you ever created the 4-layer circuit board? How are the center layers and the traces created? Does software do all the layout for you in multi-layered board? Yes. So if we were doing multiple layers, all we do is in the two-dimensional design, we can specify top, bottom, and then there's like top, there's different specifications for 4-layer boards. There's more layers in the layered software. So we would have another routing layer in this over here. I like to keep it 2 layers because 4-layer boards are a little bit more difficult to troubleshoot. I got boards in less than a week. We live in weird times. We live in a time where doing what I did with the module tester is no longer viable or worth our time. Doing this, perf boarding, not worth our time. It's madness. It's utter and complete madness. This is pointless doing this. I spent all that time modeling this in Fusion360, which is a wonderful product, but I wasted my time. It's crazy, isn't it? So we're gonna be designing a circuit board for this as well. This is all just part of this whole thing. It's insane. Like, printed circuit boards are so nice. I watched that Project Binky video from this week. If you guys haven't seen it, Project Binky is a Mini that's being converted into an all-wheel drive Celica engine and drivetrain, and it's a beautiful project because they are fabricators by heart, and they're going through everything atom by atom and making sure that it's done right. Very cool project to see somebody go through a couple boffins from England doing everything like super duper correct. However, I think in their latest video they misstepped. They had this extremely clever way of coming up with essentially a circuit board by 3D printing conductive material. They 3D print conductive material and then they solder to that after making holes and rivets in an FR4 layer. $5 for 5 of these. If they went through a PCB manufacturing service, they could have had their 4 iterations on the design much more easily, quickly, and accurately than 3D printing traces onto a circuit board. It was a really cool thing to see explored on like a professional design though. So I don't fault them for that. And they used Fusion360 in their pursuit. So like, hey, if you guys are already using this piece of software, like it does really well with creating circuit boards, you could do that. It seemed like it was a little mad considering where prices have gone. I suppose JL's PCB is probably seeing a lot more volume in their production. And so they can do lower prices and quicker turnarounds and stuff like that. Probably different settings in their machines too. But yeah, anyway, the footprint we've just redone, right? And we'll figure out slots in a minute, but I realized that I didn't load my design from the cloud. I don't know if I'm going to overwrite updates. Hopefully it updated itself when we started the program, because I'm using a lot of those designs here. This is in fact a slot. It is a slot that needs to be centered on 4.445. They produce a lot. Yeah, it's scaled up fab. So if we make this into a slot, what are the dimensions going to be? We need to go from one end to the other. Our width of the thonky pin. Now I have calipers. I could just measure this right here, but we'll just take it from their documentation. Their documentation will know what the spread of multiple different things is. 0.5 by 1.5, and we're 2.2. If I make this a 1 millimeter diameter hole, slot rather, 1 millimeter, and we need to go a distance of more than 1.5 to give it just a little bit of wiggle room. So maybe 1.7. We can be very specific with this, and so our diameter, right now it's 1.7. We're going to do, oh wait, so that's the diameter that we want then. 1.7 is already in there, diameter of 1.7. We want it to be a little bit bigger than the, what would this be again? Hold on. Numbers. 0.5, 1.7. So let's make this 1. We'll just do a 1 millimeter diameter. And the slot length is going to be 2. And then the drill hole, isn't that just going to be 2? Or do we need to worry about the drill? Unless the diameter is if the drill is 1 millimeter, or 1.016, which I think is the standardized thing. And then the diameter is 1. Maybe the diameter needs to be 2 point, you know, what it was before, 2.2. And the length is 2 millimeter, and the position would be 1 millimeter off of the center. In this case, it's 4.445. Why is that not 5? 4.445 minus 1. Let's see how messed up this happens. 3 point. Nope, mess that up. Oh, because zero's at, yeah, 4.445. Okay, so we'll keep that where it is. That is a much larger pin than what we started with. Hold on a second. Our minimum drill is 0.5, or no, 0.3. 0.7 for the drill makes it like that. And then I go to the properties and I make it less width. So 1.2. That's still a little bit wide. Oddly specific dimensions always give me pause. Yeah, I mean, this is the way it is with circuit boards. With circuit boards, we have incredibly specific dimensions on everything. 4.92. So what they've done is they've taken advantage of the fact that these thonk connectors, I'll grab my example here, are somewhat malleable. This pin can kind of move a little bit inside of the radius of the, or you know, these dimensions are not set completely in stone. This can move just a little bit if it needs to. So I'm relying on the numbers that were in the parts that I've already got, but it seems like these positions are it's interesting, 4.92, and yet ours is 4.445. I guess they figured they can squish it in just a little bit. .5 by 1.5, 0.6 by 1.5? Huh? Well, these are different widths. Ah. It's barely detectable. Let's see if the calipers can see it. 0.5 and 0.6. Let's just, oh, where are my calipers? They're on the other desk. Hold on. I go get my calipers from this desk over here. This is a lot of details to keep in your brain at one time. And, you know, nobody's at fault for being overwhelmed by a circuit board design. This is not the first time. We were doing the initial mechanical stuff and the can I do it or not evaluation. So I got 1.4 on that. I guess that's 0.23, 0.28, 1.05, 1.02, 1 millimeter. 1 millimeter, 1.05. It says 0.5 by 1.5. I guess they want that little bit of extra in there. So we know that our dimensions will fit pretty well. Never skimp on your calipers. Buy the expensive calipers. You don't want the hassle, especially if you're doing circuit boards. The mechanical dimensions of a circuit board, if you hand these over to like a machinist, they'll be mad at you. They will get angry. We're able to do some pretty wacky stuff with accuracy and dimensions on circuit boards. So yeah, our slot is looking, I mean, it looks like it's going to be a little bit more narrow. Our overall diameter, 1.2. Slot length is 2. We could go much smaller than that. It looks like it is a center slot, which is helpful for us. That is actually very helpful. I was worried that we would have to specify the beginning of the slot. But yeah, this is 1, and then our length is 2. So let's pull that in a little bit, and let's make that 1.5. And so that'll narrow our pin down. It's kind of giving us a little bit more minimal of a thing. The minimum drill size for JL is what? 0.3. The machinists are cranky anyhow. I machine stuff, and yeah, I'm also very cranky. So that can go down to 0.3. do that and take this down like that. All right, 1 millimeter, 1.5, 0.5 millimeter drill. And I think they won't get mad at us for that. 1.5, 0.5. Properties. Hello? Properties. Turn you into a slot. Why did that not? Oh, apply. 1.5, 0.5. That is very minimalistic. Now, if we're doing it that way, does that mean that we need to? Yeah, we probably still need to offset this. What is the position of this? This should be negative 3.175, and then on the sheet, these are footprints from somebody who has worked with these before, and they know what tolerances they can get away with. So their numbers are cooked a little bit. It's 3.3, whereas the ones I'm looking at are at 3.1, and this should be 6.4, but it's all the way out here at 5.7. Well, we're going to move this one in a little bit, 5.6. Probably more than that, but let's turn it into a slot. So slot, this is still going to mess with it though, because if this thing is going to be offset, it's going to be bent to the side, and so it's not going to want to come straight through that. It's going to be at a weird angle. Well, let's do it anyway. Let's do it the way we've done the other pins. So 1.5, and then 0.5. This is going to be unsolderable, isn't it? It's going to be like impossible to solder. I'm digging my own grave here. I could put this right up snug against that. Maybe I should do that. So let's put this in the middle. So we're 0. And then we'll move it up a little bit to be straight up and down. Like that. Look at that. That is incredibly annoying to solder. Amazing. Negative pi. I don't have negative pi. Actually, you have negative pi. You need to bring me pi, and then I'll eat some of it. All right, so let's see. That is incredibly minimalistic. The pins have been scooched a little closer. Actually, I don't think they should be scooched internally. Let's scooch them back up. Let's move them back out internally, because we need more space in the middle there for a chip. We need that whole chip to work. No, it's my pie. I'm sorry, master, but I must go all out this one time. So those are 4.92. So this one's at 4.92. That's not much of a difference, but it gives us a little bit more working room. And then 3.3. I don't know if I'm going to make it. 3.38. Oh, that's not that bad. That's not that bad at all. So 3.38 and 4.3, and that gets us to exactly where everybody should be according to the data sheet. We're going to have to do this all to the other one, but it'll take us way less time because it'll be super easy to do with the stereo one. Stereo one has all the same dimensions. It's just that it doesn't have the cutoff switches. So now that I've done that, I can hit save on this 2D drawing, and this is a specific variant that is going to be updated throughout the rest of the design. So I'm going to remember those numbers because we're going to need them on the other connector. And we're going to go back to our content manager, and I'm going to go to the managed stuff over here. Actually, the managed tab I could go to as well. Managed tab. And what I want to do is I want to upload this design to the rest of library.io. I guess before I do that, I want to get out of the components level view, and I want to take a look at the Donkey Kong in general. And now the 3D model is no longer going to line up with anything. Unless that didn't... I think maybe I need to redo the connection here. Oh yeah, so if I update that, fetch copy of existing, remove Donkey Kong. Let's upload to the library manager, and maybe that will update it. Although I think, well, we're gonna have to redo the 3D model as well, so we might as well get rid of. Oh, I see it. Did it make a new? No, this is this specific one offset. Yeah. There's two different models. One is the stereo one, and the other one's the. So we edited the stereo one. That's fine. That's fine. I'm gonna remove this 3D model actually, because we don't want that anymore. Because it's using components. Okay, so how do I... we may run into troubles with the software for doing this. I mean, if I attach a copy of an existing 3D model, or if I edit the 3D model, will it propagate through the rest of this stuff? Let's open up that 3D model, and maybe we can just edit it. Well, no, we can edit the package. That's what we can do. Okay, so double-click on that to edit it. And then we can edit it in place. So what I did is I was super smart, and I grabbed just that square thing and I just rotated it. I don't think you can do this in the actual part without breaking it. I was just going to bend the pin over, but what I can do is undo that and flip it back over to be straight back and forth. And then we can, I guess we can bend it up here in order to make it fit into the pad. So let's do that. In order to do that, I click on the component down here. So what this is a 3D representation of our part on its pads. And so Fusion gives you the pads that we just made in a little dotted line down here. It's hard to see, possibly because I'm using almost the same color for the part itself. Bend it like bother. There you go, yeah. Man, soccer is not as big over here in the States, but we still know who Beckham is. So you can see here that like things are actually lining up. Our pads are actually going to look pretty good on this thonk connector, and we're going to have a little bit of room in the middle, and I should have a little bit of room to solder. I hope this works well. I could maybe make them a little bit smaller, but I think that little extra tiny bit of wiggle room is going to be helpful to us. It's not much, but it's also, you know, it's nice to have just a little bit of wiggle room. So we got to correct this. So to edit in place, I have the component that I brought in, and I brought this in from my own files. I found this on Thingiverse, which if you go to Thingiverse, I found this on GrabCAD. You go to grabcad.com. It is an additive manufacturing, or like a manufacturing website. And you're like, this isn't what I thought it was. You go up to the library. You go to the like user stuff and then library. And it's this exhaustive library of 3D models. And a lot of them are done in AutoCAD, so that a lot of them are extremely useful. So anyway, I got it from there, and I basically just drag and dropped it from my files into this one, and then positioned it. From there, when I wanted to edit it in order to make this weird offset part, I actually go in here and I click the little pencil on the end. And what this does is it now gives me the full suite of editing tools as if I had opened up that document. And it helps to alleviate some of the confusion around multiple people working on parts, and the confusion of, oh, I need to update this part because the part updated. You can edit in place, and it lets you see everything at once. And also, it lets me see the pads that are actually in place that I need to align with. And you can see here, there's a little plane right here. That's the cut plane that I used in order to bend the pin in a little bit. Again, I don't know the full, hey, what's up, Copper? I don't know the full suite of Fusion tools that are available. And so I don't really know how to use the sheet metal stuff. I might be able to in another life. Maybe I can learn this at some point, convert this into sheet metal and bend it. It would be nice if I could do that. I don't know how to do that. But anyway, I'm looking at this right here, and if I open the tree of the part, it shows me that this is pin 1-1. And down in pin 1-1, it's a component, it has a body. And the body is body 2. So now I'm going to move body 2. I'm going to rotate it. Rotate body 2 around this point right here, because it's just something round. So rotate it around there, and then we're going to pull it back into being 0 degrees, which I think I can just do with regular increments. This is how I did it before. Yeah, 25 degrees back. So now our pin is back to normal. Our pin's back to normal, but we have this cut right here that I need to produce so that I can rotate the bottom of the pin. So I'm going to go split body, Body to split. I already selected the splitting tool. Select the body to split. That's this one right here. Bada bing. Okay, so that was created with 3 points from this bend. So now I've got 2 bodies, and I can select this one, and I can move copy, and I can rotate it. And what axis am I selecting? Well, I'd like it to collapse in on here. So what I'm going to do is for the axis, I will select this line. It might make the part a little bit weird, but at least it'll line up with the pads. So let's just try to get that in there. There we go. Maybe 4.5. That's pretty good from what I can see. And I could leave it like this, or I could be nice and just take the 2 bodies and I can combine them. And there we go. So that's how I end up bending the pins for these things. Now they might collide. I think I'm going to be able to fit everybody that I can, and I'll have these nice rounded slots for everything to go through. So that's done. We're done with this component. So I'm going to finish edit in place here. Now we've got the updated component in the part. So we went from one file to the other. One file was the 3D model. The next file was the 3D model with the pads. And so now we're in the 3D model with the pads inside of an editor. So one of our tabs is now package. So now I'm going to finish this package. Don't take that any other way than I meant it. I'm going to finish that off, and now we're done, right? So that's all been updated, and all the pins are still mapped and everything. You got an ad for a network switch PCB, looked about 1/2 inch thick. What are you getting all these networking? They think you're IT. Yes, hardy har har har. Okay, so we need to edit the other one. That's this one. Boop. So this one over here, we need to edit the package itself. See, it puts us into the 3D model section. We don't want to be in that. We want to go all the way back to the component, and we want to find that other offset one. So that's this one. So now we're going to double click on this, and we are going to edit the cursed footprint. So we know where everything needs to go. Properties. Slot. Apply. 1. 1.5. 0.5. Apply. And then this goes to 4. What was the number? I forgot the number. 4.92. This is going to be good. This is going to fit perfectly. This gets deleted. We then put footprint. No, yes, footprint. And then we put in, we draw a circle and 1.27. No, not a 1.27. We want to draw a 1.1 width, and we go to T keep out. T to glue? To reference? No. T stop. It's a stop layer. Go from the middle, and we go out. Just the size of the crosshair should do. Click Dune. Go properties on this one. And then we go to a slot. All this stuff we got to remember. Diameter of 1.5 slot. Drill of 0.5. And then the position is negative 3.38. Good. What was our position on this one? It was near enough as makes no difference to 5. I think we put it at negative 5, or was it at negative 2? I think it was at negative 5. And then we'll center it. And then we need to make it into a slot. Make it the jokes. I'm tempted. I'm not going to do it. Not going to make the jokes. 1, 1.5, 0.5 at 50. Apply. No, I think it was 5.2 because that's too close. That's too close. The solder is going to hit the plastic in that case. Yeah, 5.2 was perfect because we've got it just outside of that line, and that line represents the edge of the plastic of the part. So it is ridiculously close to the plastic of the part. It should be able to solder in and have the solder do its beautiful thing, and everything will be fine. 6.9. Wrong dimension. Okay, so that's all updated. Now we need to do the 3D model. I'm going to hit Control S on that. And then we go to 3D model, double click, open it up. There it is. And now we undo all the horrible things that I've done to this poor part. So we go in here. The footprint representation of the document has been updated. Dun, dun, dun. Okay, so we need to make the stuff just go back to where it goes. If the solder merges with the stick, that's just a stronger mechanical connection. What's not going to be good is when this piece heats up to the point where it starts warping the outside of the component, because I've had that happen. All of this Donkey Kong, while a great design if you're going through stuff quickly, if you're a big, dumb Luddite like I am, sitting here with your soldering iron connected to this pin, all of that plastic in contact is going to render your Donkey Kong into some kind of a wavy Kong, which is a totally different game. That's the jet ski racing one. Yeah, it's terrible. So anyway, back to editing this thing. Crediting with editing it. This component I want to edit, so I'm going to go here and edit in place. The edit in place just saves the headache. I used to go into the 3D model itself and edit it there, but you wouldn't be able to see the footprint that you're trying to match it up to. And jockeying all the files gives Fusion much more opportunity to go, ah! And then crash and ruin all your work. I've had cyclical redundancy errors and stuff like that in Fusion before. Doing it this way is like, just do it. Apparently rated for 2 kilowatt. What the hell? Why do you even look at this stuff? You look at all this audio equipment that's way more expensive than what you could ever afford. It has to be frustrating for you. It's like, look at all this stuff that I'll never buy. Okay, so hit move. I've already split these into 2 bodies and I haven't joined them back in. So I'm going to leave them split. But what I'll do is I'll go to the move command with both of them selected and just select a radius of the circular thing. And then that'll just let me jockey it back into place. We don't have to do my stupid tricks anymore. That's 25 degrees. That. Apparently not. Does that match up? Why is the little plane that I made so far off? That should be, it's not centered. Weird. Well, let's get a measurement on it then. So I'm just going to click OK on that, and I'll go to measure. And if I check this line and then the pad line, I can't check the pad line. We'll check it against this. 2 degrees. So we need to go 2 degrees in the proper direction. So select. I can't select them with the measurement tool. Select, and move, rotate, choose the axis. And we need to go 2 degrees. I have so many numbers that I'm temporarily remembering in my head. That 5 is way too much, 2. I think that matches it up. Okay, so body 2, we can now rotate. Oh, it looks like I rotated it here on this one. On the other one, I have it sticking out completely. So the other one's going to be a little bit more compact. Only fat we're here to explain. Explain yourself, ad industry. I've dropped metal pins out to many plastic bodies and things like USB-A ports. Not much heat required to murder parts of the plastic bits. That's the thing is like, you know, USB ports, they suffer from the lack of soldering time. That's what basically USB micro is killed by that. They don't solder long enough on the anchor pins that hold the casing of the USB socket. I've dealt with this a lot where you go to plug in for the first time because nothing's been broken in. It's like the most mechanical force that this thing's ever going to see. You go to plug it in and just goes pew, and just flies off the board. And because everything's surface mount, it takes all the pads with it. It's horrifying. not often that they get it right and get it completely well soldered. So we move these in 2 different ways. We're going to see what the repercussions of that are. -9. Yeah, it's good enough. That'll do. If you see on the Synthro picture, you can see that the pin goes out and does like an arc because it's under pressure. So what they're doing is they're just throwing it into each other. And what that'll do is, here, microscope is better for this. Microscope gets a little claustrophobic, but it still shows what's going on. That's what the Synthro look like. And that's what we're going to be asking this one to do. I could flatten it by just pushing down on this here and make it a little flatter, but that's essentially what we're doing. We're going to have it look like that. It's fine. It's just a ground wire. Okay, so we're done with that. Finish the edit in place. Finish the part. This is where I potentially could have messed up pretty badly, and I'm not sure what this thing does when you first start up, but we're going to merge this library with the other library that exists on library.io. So what I want to do is I want to hit upload on this thing. Those files will go to the cloud. I'll be able to bring them back when I switch machines. I didn't do that at the beginning of the session. I should have pulled the library down from the cloud first. I'm not sure what's going to happen. If I merge this, it should probably warn me about overwriting 3D models, and the 3D models will be for these connectors, these minimal connectors that I have, but they're going to be overwriting the cursed ones, which had the bent pin, and I think that's okay. So let's see, and on top of all this, hopefully we solved all the problems, because we might not have solved all the problems. We could have done all that work and still have the problems that we had before when we had all the problems fitting the components in there. Let's just see. I don't know what's going to happen. So we go to manage, and then I click upload. So upload that to the library. I don't do version descriptions. I probably should. Click OK. A new version of your library will be created. Any 3D packages uploaded through the web will be retained. Create. So it takes a little while. There's a lot of like compiling, just waiting. Making the changes to the 3D model becomes the easy part. It's the waiting that's the worst. And then when something goes wrong, like everything goes wrong. But I think we're good. We'll click OK on our save again. I've also had times where it gives me this weird issue where it's like, do you want to create a backup library? And I accidentally click OK. And so I have these weird backup libraries in my directories. Yeah, nobody reads commit messages. Well, if I was working with a team, I probably would do that. Just quickly mention what changed. So, did I edit the correct one? We're looking at number 6. We have this offset. It's the absolute minimum that we could make the pads. And then we have the other one, offset stereo. This one's just the stereo. This one's an offset stereo. It's not offset anymore. I'll probably change. Let's rename that to stereo minimum. And this one, rename. Oh, that means I'm gonna have to save everything again. Darn it! I wish I had thought of this before. Min. Actually, the other one's going to organize itself with, yeah, it should be min stereo. Well, no, why did that one go up there? It went because it was WQP. That one's also WQP. Who knows? Oh, 3 and 0. That one's 419. I called that one offset, which is now a misnomer. But all right, so all that aside, I'm not gonna hit save. We can now go to our 2-dimensional design. And I usually go into the library manager. Where is that? It's over the design manager. And we want to do, what are we doing? Not the design manager. Place components. Yeah, there we go. Example libraries are now in library item. Oh, whatever. I don't like using the example libraries. The libraries that I have are components that I've used in other designs that I know work. So anything that's in there is mostly vetted out either by myself or by SparkFun. I don't trust a lot of other outside sources, or there's things that I've made myself and used. I probably should have made these into slots. These should have been slots. They're giant pins, but the pin itself is this thick tab material, so having a little slot on that would have been great. I'll have to take that under future advisory, because we do have to redesign this one. There were a couple little errors in it that I need to fix. But we don't need the VCO right now. We need a module tester. I got nothing to test these modules. Test and tune. This is really what we should be working on today. But Julian called me over the weekend, and he was just tears streaming down his face, and he said, you know, oh, bother, everybody loves you. Everybody talks about you all the time. And they say to me, sir, they say, I love you. And no, he called me and he texted me, and he basically said, I'm looking for a specific module that I can't find. And that's stereo mixer that fits in 2 rack spots. And I was like, what does that mean? So I whipped up a 3D model, and I went, dear God, how do you fit any electronics in this thing? And that hooked me. It hooked me into this design. It's a challenge. So we're trying to minimize the pads and the pad stuffs that come with these components. Then we're also going to have to make a board edge cutout for the knobs. And I can do this with a couple different methods, but first, let's take a look at our handiwork. So in order to get this updated, in my place components dialog, I've only selected the libraries that I use. I've deselected everything else. We can open up the library manager. We can see, like, if you go in use, it'll get rid of all of these. I don't know where all of this stuff is, but boy, oh boy, is there a lot of garbage in the libraries. This is not Crescent Fresh. This is very confusing and weird to look at. So in use is what I do, and I only select my stuff for in use. But we need to update the libraries. I'm trying to remember how we do that. I think if we go into library, we can update design from all libraries used in design. So we're going to update everything. Modified the board. So now we need to check design rules and stuff. Well, I'm not going to check the design rules, but what I am going to do is I'm going to go into the 2-dimensional board. And now all of our pads have changed. What this does is my clipping indicators are now actually running into those components. So I'm going to have to drag these to the side just to make sure that everybody is happy. Yeah, that ain't kosher. We're going to have to twist this one around, and we might not have room. We might not have room for the clipping indicators, which would bring with them 3 new op amps. So that you know, maybe is not something that I can do. Okay, hold on. Let's get this out of here. Okay, so these 2 pads, although they are both grounds, they do conflict with one another. They're both ground, though. The myth of self-documenting code. Yeah, somebody will figure it out. So right-clicking, I can just flip it around. Now, why is that offset by a little bit? It for some reason, it went to 5.16, so I set it back to 5, and that'll jockey it back into place. This is getting a little close here, but one of these does need to be flipped. All right, so let's pull everything out, I guess. Which way are we going to go with this? Well, if those are facing downwards, that needs a little bit more space. The question is if this is going to ruin my design. I think we can fit everything. If I drag and drop from the right side, it will only select things that I've surrounded with the box. So if I go below my board edge and I go from the right side, sorry, left side to the right, it will only select the components. If I do the opposite, anything the box touches gets selected. And if I try to move things, I'm moving everything. It's going to move the board over to a weird empty space. So I want to select from the right side, go to the left, and miss this and hit all of the grab points of the components, because we'll pull them back in. So pull these out of the border, and then we're going to put them back into the border in their min-maxed positions. So J1 will not allow me to go any further than that. That's the minimum for that. That is our stereo connector, by the way. Now, do I want the pin to go down that way? I guess so. And we get the potentiometer as close as we possibly can. I can hit Alt to go to a different grid. The grids are important to get right. For right now, I just have the defaults, 1.27, and the multiple's 1, and then the alt is a fraction, a tenth of 1.27. That works out some of the time. When you're building a circuit board, especially with through-hole components, you're dealing with a lot of metric and English sizes. The SO8 standard, I don't think that's is that a millimeter standard between the pin spacing? I forget what it is. Sometimes you deal with English standards that have creeped into what we now commonly use. Everybody's using millimeter. It's just that the electronics standardizations were originally English because electronics have existed for a long time. And so we as engineers need to be able to work in all of the above. I would appreciate if I could just do everything in metric, but pin spacing is what it is. So I'm leaving this to the default just for our purposes. Go to the properties here. We can see that we are at 5, and I would like this to be as close as possible. And I believe that the 3D footprint, that this footprint represents the 3D footprint. Let's check. This isn't updated. This is still our old design, but I can see where this thing might step out of line. It's pretty much exactly to where the silk screen is. So as long as we stay within the silk screen, we will have enough room. We didn't fix the clipping on this thing yet, but I don't think we need to. We can just leave that to be a little sloppy. Okay, so back to the 2D design. So as long as I get it pretty close, and I should probably standardize how close these two can get from one another. Yeah, 100 mil or 2.54 tenths of an inch. But I don't know. I work in millimeter a lot of the time. God, this is going to be so confusing. It's like 6.272 to 18.411. What is it? Subtract one from the other? I'm not doing that. We're just going to drag things into place. So this needs to go this way and as close as possible without forming a solder bridge. Probably a little closer than that. Let's go there. Yeah, it's I don't know. The grids, I have trouble setting up the grids properly. And the thing is, because these are being like laser etched or whatever onto the board, they're all so accurate anyway. I work in Imperial because, I work in millimeter because Imperial grosses me out. I mean, that's valid. I'm in America. I'm an American. So I work in America units, but I think in America units, I work in millimeter. This is kind of the feel-good distance. This is a little bit, I guess that's okay. And we're doing, it sticks up from there, and we get it as close as possible with alt spacing. Just a little bit of a line in between them. So as you can see, I'm doing this by feel. Doing this by feel right now, just to see what I end up with, if we've got something viable in the end. I'm an American, but I'm also a nerd. Valid. Valid. Yeah, in electronics, you really need to be able to just work with whatever. You get a drawing and you're like, oh, they're doing this in angstroms? Okay, well, today we're working in angstroms, I guess. I do wish there could be some of the sketching tools that Fusion has in here, so I could do something like measure the distance between this edge and this, and then use like a construction line to put everything on the middle. I know that Eagle has some layout tools, but I don't know to what extent. Oh, look at this. Look at what we've done. What have we done? Because of the spacing of that pin. Oh yeah, I can't shift click and go into 3D view. I keep trying to do that. Yeah, angstroms per fortnight. I realize now why the very first thing that they kicked us off with was doing an absolutely obnoxious amount of dimensional analysis. Cubic furlongs per fortnight. Wait, what is a furlong again? Damn it, this doesn't fit. Now, my board edge spacing is at default. If I get it to be with the standards of the PCB Design manufacturer, then maybe we can get away with it. If I can get this a little closer without it being like solder bridge close, that is pushing it. That is really pushing it. And I don't know if that center pin is going to be ground. They use it to measure throughput of dams. So it is an actual measurement. So you're saying there's a chance. That gets it to the right distance, but I've done things that I'm not proud of, like this. Ugh. 5mm. 5mm. I can be a total stickler about these distances and stuff and get it all to be laid out evenly. I mean, I wonder if I can use some of the layout tools. Now, this is an 0805 LED. If I go to an 0603, I might be able to sneak it in somewhere around here. Or like in between, like right here. That's pushing it though, because we've made this a much more narrow distance. Or we just toss the clipping indicators. We don't worry about it. I know that there are also illuminated knobs, but I think they're kind of cheesy, so I don't want to use those. No, they can't shine out the TRS holes. I got an LED in my TRS hole. So the Thonky Kongs are very opaque, and it would have to have something not plugged into it, in which case it wouldn't be shining anyway. So, unfortunately, no. Everything is blocked. Some people have LEDs in their wires that indicate signals running around. I guess that's one of the advantages of having like 10 volts peak to peak on your audio signals. So theoretically, all this stuff should work. We're going to have a bunch of ICs that are floating out in space. Let's take a look at it before I try to drag the IC over our new pad. So I'm going to create this and things will just be floating out in nowhere. Get a micro drill and just poke a hole in the side of the Thonky Kong. Just right here in the inefficient part of it. It is kind of inefficient. You put a micro LED on that. Put a little LED just right there. I mean, that's what keyboards do. They put a little LED right there. Where's a 3mm LED? Hold on, just for the hell of it, I just want to look at this. Thonky Kong is not the most efficient design. It's just very convenient for this stuff. Yeah, if you do surface mount, you could do multiples, but 3mm is kind of pushing it on the Thonks. That's a little bit big. I'm here to reinforce the voices in your head. You're already the voice inside my head. The thing is, the nut has to fit on top of this, so pushing it, you might be able to do surface mount LEDs on both of those, but I'm putting this back. I'm putting the LED bin away. The LED bin is dangerous. A 3mm LED I do not think could fit in the middle of those two either. We can check, but the 0805s are having trouble, so I think a 3mm is not going to have a good time either. A 3mm LED sticking up from here would be a little bit tight, but it could be done. Let's check the pads on a 3mm LED, because we can. Because we have that ability. We have that ability. And then we'll check to see, because this, not having holes in the board has opened up quite a bit of real estate for me to put down electronics. These are kind of pushing it. This is a little tight. It's a little tight, but we are in a design where things are incredibly tight. I don't know if I need to go to round pads on these. I might need to. And actually, we should probably make a compact model where I press this in. I just basically cut the 3 of these off and just scoot them in. An acrylic washer on the that would be neat. You'd have like the clearest washer you could find. This is getting out of hand. Now there's 2 of them. Let's first make our compact knob. So I'm going back into my library. I didn't close it. I have EC11 is the encoder, and then we have Pecker for the part number. That's the encoder. We're not doing POT US. President of the US. Oh boy, let's not talk about that. My brain. Narrow, and then narrower. Narrow button. Wait, narrow BNT. Oh, narrow bent. So that's the one we're editing. Narrow bent. And then we're editing the 3D model for pot narrow bent. Pot narrow bent. We're going to edit both the 3D model and the footprint. I'm going to start with the 3D model. I'm going to turn these into slots. Why not? If the pins are going to look like this, although I don't know if they've got that bump on the back. I don't know which ones. Narrow butt, thick, please. We are so not doing thick here right now. Everything about this is as narrow and thin as possible. I'm so sorry. Edit in place. Bonk. Now we're editing this 3D model. The question is, which one are we editing? Okay, I made a variation that says bent for the... Is that for the 3D model name? Yeah, bent. Okay, so this is a variation of the 3D model. So we're not editing our original 3D model, we're editing a new 3D model. If we did edit the original one, we would hope that the timeline's on so that we could roll it back. There are some things in place with Fusion that can help you with stuff like this and not totally ruining your day, but sometimes there's a breakdown in that stuff. So in order to split these, we need a plane to split them with. So what I'm going to do is go over to construct. Construct is where you make planes and axes that'll help you make, like, and I still have to master this stuff. You can make a 3D model that you open up and everything looks nice and simple. When you click on something, you can have like a mechanical action happening. That's what I need to do with the 3D car model, the RC car model. What I need is a plane through 3 points. I could do a plane on a surface or a tangent, maybe offset and have it not offset. I like doing plane through 3 points. It's easier for me to kind of like conceptualize. So I'm going to go here, here, and here. And there's my plane. Boom. Now, down here in this part, what bodies do we have? Body 1, body 2. Body 2 is the knob, because these come in different length flavors. So go to library, get bent. Exactly. Precisely. My God, he's got it. Body 1. Body rockin'. Body rockin'. So we take body 1, and we can still see the pads down here. They're barely visible. Body 1, and we are going to split on a plane. And for the splitting tools, we choose plane. Give me plane. And that will split us into so many bodies. So we select the bodies we want to move. Oh boy. This one. Boy, all this work to do something that... Oh, I'm hitting shift. I shouldn't be hitting shift. All this work to do something that just takes you like a pair of pliers and like 2 minutes to enact. Scroll, 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 scroll. Between Blender and Fusion, I prefer Blender or Fusion's camera, because Fusion will refocus you on whatever the first thing it hits in the center plane of your vision is. So right now, if I'm scrolling and I end up not moving at all because I've accidentally scrolled into microscopic proportions, it will recenter my view on that first thing that it sees. That can get a little annoying at times, but for the most part, it makes it so that whatever input you're doing with your mouse is realized and actually useful. With Blender, I don't have a number pad on both of my keyboards. Both of my keyboards are tiny because I like to have all that mouse space because I'm an idiot. Oh, hey, Ayademi, thank you for subbing for 2 months. Ayademi. Thank you, thank you, thank you. Yeah, number pad, dot, and Blender to recenter. If I had known that, maybe I'd have a better time. But for the RC car stuff, I found myself struggling with being way too zoomed in and not having the effect on the thing that I was dragging and dropping. I had to zoom out, look at it from the side, and then slide over to the thing. I had to be aware of where that point was in front of me that my vision was zoomed on. Fusion takes a little bit of an extra step, and it recontextualizes based on either what you're clicking or what you're looking at. That can get annoying, but it can also be very, very useful for zooming in and doing the little things. So I'm going to view this, well, I could view it from one of the fixed views, like this. And now everything is orthographic. So it's like a flattened drawing. But I can't really make out where, I guess the center of the hole is there. So we just need to get this close. So I'm going to hit move on these 3 bodies. And we're going to slide them. I'm just going to do it by feel. And I'll do it to there, because then, oh wait, no, but I can go a little further in. I can do more. All right, we'll take it right before it starts clipping, and that's a little inaccurate to what the part's actually going to be like, but you know, this is the bent pin variant, so. All right, and I could make this all into one body again, but I'm just gonna leave it the way it is with multiple different bodies. I don't think it's gonna matter that much, just as long as I unview the construction plane so that it's not visible in the part when it gets all the way out to the design. I didn't do that for the other ones. There might be a little construction plane visible on those parts. I'm not sure. Mahalo, subbing 62 months. Mahalo, thank you so much. Hey, I appreciate you guys. It's been a lot of fun doing a purely Fusion stream, thanks to Autodesk Fusion360. No, sorry. The copy that I have came to me for free because I'm doing a Fusion360 stream. If I do a couple of these every month-ish, month-ish being maybe 1.5 months per doing one of these sponsored streams, I get to do the Fusion stuff that I would do anyway, but I also get a free copy of the software. So it's a nice little mutually assured destruction. No, that's not the right one. A parasitic relate. No, that's not the right one either. Sort of a symbiotic. There it is. Symbiotic relationship. They get advertisement on the back of Bother, and I get a free piece of 400 and some dollar software. Mutual parasites. We're sucking each other's butts. Can't be separated. Just sucking those butts. Okay, so that is our updated potentiometer. Yay. We've updated it. We need to update the footprint to be as minimalistic as possible. So we're going to do the same rules as we did with the Donkey Kong so that all my pads are just about the same thing. We're just going to make it big enough to actually fit the Thonk potentiometers specifically. So pot and arrow bent, we go over to footprints, and we go to the footprint for pot and arrow bent. Mutually assured benefits. What? Assured. The language center of my brain is starting to break down. Time to look at the clock. It's 3:50. Okay, we're fine. I got plenty of time. I've been gibbering and going at 100 miles an hour. Keep in mind, if you do this stuff, if you want to do the same stuff Bother's doing, you can hit pause and wait until I get to the next thing, or fast forward through the tangent, because this stuff is something that is like practiced with me. I've done this a lot, and you kind of get used to the process of how to, you know, edit and manipulate all of these parts and what you're supposed to and not supposed to be doing at all the steps of the way. If you do something a little bit out of order, which I've done, you can get into a lot of trouble with software becoming dependent on previous versions that have updated to new version. It gets real messy. So keep in mind the order of operations that I'm doing overall here. But I am working very quickly because I didn't want to get stuck in part generation. Unfortunately, we're stuck in part generation because we have an absolutely brutally minimal amount of space to work with here. So, and I'm trying to use the biggest electronics that I can use inside of the restrictions of what the PCB manufacturer is going to set. So we need that Thonk potentiometer. So I guess we're back to, let's just do Thonk. Thonk pot is a very strange thing to search. Alpha 9mm, not quite what we're looking for. We're looking for this guy right here, Thonk. It has an official part number. We're just going off of what Thonk uses because a lot of people like to use them, and I want my device to feel like all the other synthesizer stuff Julian has, or he's going to get snippy with me, and I just don't want him to get snippy with me. I just don't have that in me. He's going to say, it doesn't feel right, it feels cheap. And then I'll cry. Okay, so our tabs are not given very much dimension here. This is very blurry. I love how blurry this is. Can I get one that's less blurry? Oh, that's interesting. So I could use NV jacks and then use the tall one. Huh. I guess this works with everyone. Neat. I'm so zoomed in on this page. Get me out of here. Okay. Doesn't matter. Tall, short. I'll take them all. You. Oh, they have all the ones with the center detent and stuff. That's nice. I could have used that in some other drawings, other designs rather. Yeah, they don't. It's not a PDF, so we don't get to read the numbers. Your mom feels. How fucking dare you? My mother is expensive and classy. Okay, so I could either measure these. I have similar ones, and I guess I should probably base it off of the ones that I have, and I'm going to inevitably use in this design. Let me get one of the ones that I have. I've put them in weird storage spots. Actually, there might be some right here. They're there. Yeah, okay. These are alpha derivative ones. They're not the exact alpha ones, but they still feel just fine. They don't feel cheap. These might. These ones over here, these might feel cheap. These look cheap. They feel just about the same. But anyway, these are the ones that we're going to want to use. Right here, these green ones. It is green. Huzzah! Bonk. You get out of the way. It's good to have the hardware on you that you're going to be designing with, because you can run into all kinds of weird shit, you know, with the actual hardware versus what's in the data sheet. Like, for instance, the pin layout of this thing, these pins underneath it, I could definitely fit an IC right there in the middle. Oh, the temptation is so strong. Hold on, where's an SO8 on a thing? We've got to answer these questions that I have. I have so many questions. Where's an SO8? This one's smaller than SO8. That's a much smaller one. And also the pins are going to get in the way, but what is that height? Maybe we can just do this by the books. Two millimeters? 1.9? What is the height of the... I don't know if I had something with an IC open. Hold on, cancel. Our theoretical IC height, that's over here. The IC we put outside of the board. It's way over here. It's in a cursed spot. This plane to this plane. Oh, don't you do this to me. Don't you do this to me. Not you. Not you. I could fit an IC under the... Hold on. Let me get an SO8. We'll get something out of the drawer down here. There's no way. There's no way. No, those are all voltage regulators. Not at a time like this. Dual op amp. It's very good, actually. This is a TL07 too. Here we go. Here's the exact part that I was going to put in. I got tons of them because we started to do modular synthesizer stuff, and they're oh so very useful. Incoming cleverness. More like incoming yak shaving. I don't think I'm going to do this because I don't think I can do this in good conscience, since you can't exactly get to these to like probe them if they're under a potentiometer. But technically, I have space under the potentiometer. But I don't think the software would really like me doing this. It's one of those things. It's like, if I really, really wanted to make it super compact, why would I be using these? I would be using the, what is the BGA version, the ball grid array version of this chip anyway, because I could fit more of them in there. But it does seem like I could potentially have space for an IC under... That's the wrong way around. Hold on. Cleverness equals yak shaving? Yeah. Jam a probe in from the side. Don't you tempt me. And isn't that how we all got here? Isn't that how we all got here on this big green earth? By jamming a probe in the side? I'm trying to get it on the tweezers so that I'm holding it flat. I don't have a suction pick and place available at the moment. And the side is kind of annoying to grab. Hold on. Oh, come on! The side has a slope to it, which makes it like impossible. You little bastard. Just let me grab you. Damn it. Oh my God, that looks so close. I haven't tried doing a manual hot plate reflow of the BGA yet. I'm still too afraid. I mean, I don't know if I have any tips. You just do it. You know, you just do it. You get close and everything will be perfect. You just got to be real careful when you're placing it down on your solder. I'm going to say this won't work just because I don't think my little brain can take it. But if I shaved that pin down, shaved off this pin, I might be able to fit an SO8 under the pot. That's crazy. That is crazy. Things I could do to impress modular synthesizer people who look at the circuit, which is like nobody. I'm not doing that. And if you don't get close tiers, yeah, testing them is the worst. And then reballing a BGA is the worst. It is the worst. The BGA stuff that I've used has been like 4 pins or 8 pins. I'm not doing this. No, there's no way. You can't convince me. 0.85. 0.4. Those are the only dimensions. So 0.85 by 0.4. So we will go with slot. Apply that. So it would be 0.8, 0.4. This would be very close with a 0.5 drill. And then the length of 1, we could do 1. We can do 1. It's got to be 1 because otherwise there's just no room for anything. Oh, other way. A drill of 0.8 and then a length of, no, what was it again? .85 was actually the length. So this can go down to 0.3. The minimum size. And this length would still have, is that right? Oh boy, I've gone worse in the opposite direction. Point, drill of 1 millimeter. Length of 1. Why doesn't it let me do the, Drill's too big? Oh, yeah, because the drill's the other dimension. Wait a second. Well, I'm getting 0.43 on the thickness of that. So if that were 0.5, what? Is it in the wrong direction? Wait a second. I guess I need to turn it angle. Yeah, that's what it was. Okay, so slot length, we need to, jeez. My brain, 0. There we go. Okay, slot length is 1, drill is 0.5, that barely fits the pin, and the diameter is 1. That's more like it. Okay. Yeah, the angle, brain. Google put a class action notice against Google in a spam folder automatically. What the fuck? That's crazy. So this would be the minimum pin, and we are barely, our drill size needs to be a little bit bigger than that. So let's do 6. That is very, very narrow. That is a very small pin indeed, and it's barely going to fit this wire in it. I mean, I got 0.443 pretty consistently. My calipers return to 0 pretty nicely. They don't have a lot of junk digits on it. So 0.47. So it is, I think 0.5 might have been the width that we originally stipulated this thing. So 0.6 is barely larger. I guess it's okay. Slot length of 1, we're getting 0.8 on these specific alphas. Obviously the pin in our main design is different, but 0.7, yeah. And then the distance I'm gonna have to check over, but okay, so 011.6. Properties. 0, 0. Oh wait, first we gotta slot it. 011.6. Very strange symbol on that thing. This is a lot of parts editing. 0. Oh wait, slot. Bring that window back into where we can see it. I should probably make a VTuber design for this stuff so that we get more of the screen. 011.6. This is just brutal. This is a brutal lack of space here. So the position of these vertically is 6.192. Yeah, 6.192. .9, 6.1. Yeah, I think that lines up with the edge. If it is centered on this plastic body, 11.8. It's almost 12. So 6.1 is barely off of the edge. So that, I guess that works out. Someday I'll treat myself to mid-tutorial calipers. I'm telling you, like these, I mean, I've heard it quoted with the mid-tutorial that you can throw them in a toolbox and it'll get rattled around and it'll still give you accurate readings. But for me, it's just the repeatability of these calipers is amazing. 0.01 of a millimeter is a very small amount of distance. The edges aren't super sharp and hard to handle. And generally just, I mean, the mid-tutorial, they just last. I keep them on a desk. They stay in a 70-degree climate-controlled room. They're not banged around too much. I do a little bit of machining and I do a little bit of scratching with the tips. They like it all. Why do my hands look like they're going to blow up? I don't think my blood pressure's that high. I think we just don't have a lot of light over here right now. My hands look like they're going to blow up in a blood fountain. Anyway, the camera gets a little weird with its color coordination. But yeah, mid-tutorials, like you spend $150 on those things, and that may be a lot for something you use to measure stuff. But if you're doing electronics, boy howdy, do you want to have accurate measurements, because I have been bit so many times by that snake that it's just silly at this point. So, okay, so here's our potentiometer. We've minimized the pin size and amount of soldering pad. I'm going to be very annoyed with it, but it means that we might be able to sneak 1 or 2 traces in between these things, maybe just 1. But the last pair of calipers you'll ever buy. I had 1 pair go bad on me. I don't know, something happened to them. And at some point, somebody had, probably me, ruined these 2 things on it. But those calipers were old. Yeah, it's something like 10 years until you'll need new calipers. So you buy a big box of batteries, big bag of batteries for them. And then, yeah, the $150 mid-tutorials. And you keep the carrying case nearby just in case you need to transport them anywhere. And they last many, many years. They're very worth the amount of money that you'd spend on mid-tutorials. You can buy plastic calipers, right? You know, not everything has to be a mid-tutorial, but for your main, the ones you're going to reach for first on the shelf, treat yourself. All right, so this is done. We are done with this one. We don't need to do anything else to it. We finish this. I hit Control-S. I hit OK. Wait for this thing to do its little song and dance. Now we can update it to everybody else, create the library on library.io, and then it's going to load it back in. So these are managed libraries. These are managed by library.io. If I need to make certain parts, I can use the online library.io interface, and that way I don't need to repeat making an SO8 and stuff like that. Supposedly that would let you share your libraries with everybody, but I guess they put the kibosh on that. They boshed our ability to share parts. It would have been nice. I think we're done. I think I go back to the schematic and I hit update Update design from all libraries used in design. That's the button that I know works. I know the other button didn't quite work. Package offset is not present in the new version of the device. Huh? What? Okay. Oh, if I unclick, oh, what's going on? Stuff is still happening. This is where the whole thing freezes and everything goes to crap. Maybe I haven't saved it over here. Uh-oh. Uh-oh! I think we've crashed it. We've done too much. I'm going to give it time. Maybe it'll sort itself out and all of our work won't have gone to dust. We want to remember all those numbers that we used. 1.1, 0.6, 0.5. Oh, God, I don't remember anything. Uh-oh. I got a Harbor Freight plastic set. It's the tool in the box. My mid-tutorials are on my desk. Yeah, that's a good way to do it. Everybody needs to be saved, but I think my program is frozen. Well, oh, here we go. Update. Oh, so it keeps opening this dialog, but it's under the program. Cancel. Cancel. It's a dialog box that I don't know about. I'm going to go back over here. Go away. Okay. Save that. Make sure it's saved. Go back to this one. Save. And then I'll try updating and see if it doesn't bark in my face about it. Maybe it's because I renamed the footprint on the one. Do. What are we doing? PJ 3100 something Donkey Kong. What does it want me to do here? Package variant offset. Oh, I see. Min. This is the PJ 301. Is that for PJ 301 Donkey Kong? I don't know if that's the stereo one or not. Let's just choose the minimum one there. And then it's going to look for the same thing. Yeah, so I renamed it, and I guess renaming it made everything go stupid. So I need to do it for all 4 of the connectors. Jeez. La, la, la. You would think that it would retain its associations if I renamed something, but apparently not. 31 blah, blah, blah. Donkey Kong. This would be the last one, and so this would be minimum. And then it's going to ask for... No, it's not. I guess it retained the stereo one. Okay, there we go. So now everything's updated. You think that, but programmers are lazy. Yeah, it's weird corner cases for everything. Okay, look at how much smaller that is. That's nice. Maybe I should afford it the same distance in width, but we've got these 3 pins next to each other that I'm going to want to be able to... I want to be able to maneuver around all this stuff, so... Only the cheap ones because my battery cover disappeared. Oh, I hate that. That's the worst. So we're still not really going to be able to fit the LED in there, are we? Let's see what it looks like to have a 3mm LED. I have a 3mm LED footprint. So we'll just turn this one. We'll right-click it and go to Package. And then we can change the package on a whim. Oh, it looks like these are only surface mount. All right, so let's add a new LED. So place component. Place component. And we're going to go to the... I guess it's a component. So I'll go to component. And I'll go down here to LED. And in the variants of the LEDs, I have a 3mm LED that is 10mm offset from the board, just as a thing to help me with all these modular synthesizers. So I'm just going to haphazardly throw that into the design, click done. And then we'll go over to the 2D design and we'll have the footprint hanging out near origin. So that looks totally untenable. It looks very hard for us to place. If I could just get the pads in there and not have them interfere with something. But it doesn't really seem like I'm going to be able to do that, unfortunately. If I do totally minimal pads And they're just two little slots. Maybe I could do that. Do a minimal diode. Oh boy. All right, back to the parts manager. Oh, this sucks. Every single thing I'm doing, I have to redo the part. I have to make a new part. This is mechanical, so that's the wrong library. So we need to go into the library editor, which I guess we can get to from here. So I'm going to edit the component. I'll have to make a new variant of LED. So go down to LED, and we will take LED 3mm with the 3D model that's 10mm offset, and I'm going to duplicate it, and LED 3mm min. Although they're square leads, so I don't really know how minimalistic I can get this thing to be. But these are pretty chonky leads, so let's just see what we can actually get them to be. So for this, I need to bring out a 3mm LED again. The other part is, will it clear where the between the Donkey Kong connectors? If the leads are squished, I think I can manage it. I mean, the alternative is to use like an 0403 surface mount in there, but carefully machine the leads. Yeah, let's sand down the leads. .4 by 0.5. Oh, great. 0.4 by 0.5. So 0.5 by 0.6 would be our slot in this case. Oh boy. 0 angle. Diameter. 1. Slot length. 0.6. Drill. 0.5. That is our minimum LED lead, and I hate it. And I hate it. Slot, apply. It's going to be very annoying to solder. Oh, dear God. All right, let's see. This is ridiculous. And so let's see. This does not have the 3D model associated with it. I'm going to hit save. And then I'm going to open. Oh, wait. I didn't close the dialog box. Diameter 1. Length is 0.6. The drill is 0.5. Fly. Okay. All right. So this is going to need a new 3D model. So I'm actually going to go into the overall component manager, and I'm going to open up LED. 3mm. Where is my variant? Oh, it's a variant of the package. So I need to actually make a new local package. New local package, and it's going to be the one we just made. So it's going to be LED. Oh my God, there's a lot. There's a lot of LEDs in here. Why are there so many? This is where all of my LEDs are stored. There's a lot. LED 3mm minimum. The 3mm LEDs are nice because you can get smoked ones that look good in the front panel. Now, it's a really, it's a good job for a very tiny bench grinder. That's the footprint, but we do this one, and the variant would be called minimum. What is this one called? Model 3mm at 10mm. Min 10M. So min 10M. Attach a copy of a 3D model. So what happens if I do that? If I do LED If I attach this 3D model, what's going to happen? Will it get confused? It'll want to save a new file. Well, that should all work out. Just that, well, it's got a placeholder. What the heck? Huh. New local package from web. Go over to here. Take a look at this again. Let's like reopen this. There it is. Okay, so yeah, this does have. Okay, yeah, that worked perfectly. All right, perfect. We just need to connect the pins. So anode and cathode, connect, connect. I don't know why they use the letter K for the cathode though, because it's spelled with a C. Okay, so that library is ready to go. Click save. Click OK. You got to do the right steps or things start getting weird. That's why I got a little worried there that it had a placeholder on it. But apparently reopening the part updated it. So everything was nice and updated. We didn't have to do any superfluous savings. We go to manage, and then I click upload. Create the new version of the library. That's going to back everything up and allow me to move to a different machine and you know, keep working on the design. I didn't expect this to get bogged down by parts creation, but the allure of using extremely minimal pads for everything and being able to get us all of that space back for the design is present. There's still floating over my head is, can I actually fit all this stuff on here? I don't know the breadth and width of the design that I'm going to be putting in here. At least I know that I'm min-maxing all of my space, but once I'm min-maxing all my space, what if I need 5 to 10 op amps? What if I need multiple, you know, 14-pin ICs in there? We saw what Synthrotech is able to fit, and I think we should be able to do that within the limitations of our software. It's going to get a little hinky when we have to run traces back and forth. This is going to be very much a challenge design. So now that I've done all that, I can go back to my 2D design, not 2D, my schematic. There we go. And I can go to the package here, and I can choose, well, we haven't updated the library yet. So I need to go to update design from all libraries, let that propagate. You're not gonna do anything? All right. Go to package. LED minimum, 10 millimeter, click OK. I don't particularly like that model of a 3D, the 3D model of an LED, but we've lived with it. We've had that model for like half a year now, so I guess we just got to live with it. It's too clear. Ew, look at that thing. Ew. Now, there's no way in hell that any kind of an LED is going to fit in this design. Nope. Just simply no. The answer is no. The answer may surprise you. It's no. It's no. The answer is just no. It's just straight up no. Just for fun. Can I put a diode there? It's either a like size of a grain of sand part going in or nothing. And we may just not have clip indicators. I can do them out the sides. No one's, you won't see it when it's in a rack. All right, give the computer room to breathe. Yeah, no, I'm going with no on that one. I don't like this model. The pins are too dark. There's just no way an LED is getting anywhere on this. Unless I somehow try to, well, no, but the problem is the width of the thonky pins keeps me from putting an offset LED. If I do the pins vertically, but they're not going to fit anywhere. Like the 3 leads coming off of this have no room. So it'd have to be like vertical. It has to be horizontal over there. Yeah, it's just not going to happen. All right, so that being said, let's see what a tiny surface mount LED is going to look like. We can just delete this. Oh, that worked for nothing. Okay, so over here, and we go to change the package on this one. Yeah, just have the LEDs on leads. have a second panel with all the LEDs on it. Package. It's a shame you can't light those things up alternatively, though. You could do illuminated knobs. A lot of synthesizer equipment I've seen use those illuminated potentiometers. But given Julian's track record and how I've seen the horrible things that he's done to certain components with knobs, I would not trust him with an illuminated knob. He would break it, and it would be like a $5 part. So, 0402. This is a masochistic size to solder stuff in, but it is an option. So let's see what that looks like. We're going to have one 0402 LED on this, and we could potentially fit it in several areas where we would have a hole beneath it that would shine through. Dear God. I guess I could do it that way. This might fit an 060 or an 0603. I think that might fit an 0603. It's close. It's getting real close to the point where it might interfere. But let's just see what. Oops, not properties. Right click, go to package. Package. We'll go. Now there's the 0603 flat, and then there's the ones with a little jerky outy thing. Or there's the 0.8mm one that's this big chonky thing. I'm going to go with the big chonky thing. It doesn't really matter. I'll do the one that takes up the most amount of vertical space, just so I remember that they're there. I'm going to change all of them to that, because I think that's what we're going to end up using. And I could use the change tool to do this. If it's in this menu here, you can use the change tool to edit it, and then it's just one click to change all. Oops, that was one we already edited. Oh no, 0805. We're just going to pop down to 0603. Package, 0603, okay, and then move over to the 2D design. Oh no, I've gotten close on this side. Yeah, shut up. There we go. Just get that in there. So we can sneak these sort of right under and next to the thonks. And while I keep wanting to hit shift and then center click and it to flatten out into a 3D model. God, it would be cool if they could do that. Come on, AutoCAD, get on it. So I've got a knob on the top, knob. And at the bottom of each, that might be confusing. Like each knob could have an LED next to it that would indicate whether or not it's clipping. In which case, these all move up. I'll be right near the connector. Because this one is this circuit down here. I'm not going to have L and R individual clipping indicators, am I? I could do an LED on each side of the Donkey Kong jack that would tell you whether or not it's clipping, but there's no way in hell that I'm going to be able to get traces in and out. I'll put them like that just for now, just for display purposes. It would really be a dual clipping indicator from each knob, in which case I'd want it to be associated with the top or in between the two, I guess. If it's in between the two, then it indicates whether or not it's clipping. I put it just like right there. And this one would have to be all the way down here with this one. Those would correspond to just a hole in the front panel where the LED would shine through. Okay, so to the 3D design, and then, of course, pièce de résistance. Yeah, look at that. Beautiful. Now I got all this space around these things, and I can put these right below where the thing plugs in. I can just kind of like put the chips wherever I want. The question is, can I fit a 4 amplifier chip under there? All right, let's see the 3D design. Burp. Push. What's up? I'm from Turkey. Welcome, welcome, welcome. We're getting through a very minimalistic modular synthesizer design. I'm trying to get one circuit board worked out. 2 layers is going to be pushing it, but we're using Fusion360's wonderful capability, or Autodesk Fusion, I think I'm supposed to call it. I'm really bad at this. I'm using Autodesk Fusion in order to plan out the three-dimensional properties of this board without having to go through 10,000 iterations of me poking myself in the finger with a soldering iron. Look at that little guy in there. If I really wanted to go super duper crazy, I could put two of these guys in and have one for good and one for positive and one for negative. I don't think this will be control voltages though, because this thing is a headphone. Are you electrical engineer? I have received a paycheck for my services as an electrical engineer. Yes. So I am indeed, I do count, although our country doesn't re-examine, I don't have to like retake any tests in order to, you know, retain my certification. It would be kind of neat if I had them going positive and negative, but this thing is meant for audio signals, which can be plus minus 5 volts, I believe, inside of the synthesizer. The M303 we were testing was plus minus 3 volts, so I'm going to have to order a bunch of chips. I think among them, I am going to be ordering the 4 VCA chip, 4 voltage controlled amplifier chips. They're like $5 each because they're coming from a custom manufacturer, but they do solve a lot of the issues that I'd have in the circuit. I'm still determining what the specifics of the circuit are going to be, and whether or not I can fit enough hardware to do clipping indicators and everything else. Like, what is this going to look like? Well, the front panel, and then we'll have a knob above the two things that you're mixing, because the two things you're mixing will be wires that are flying all over the board, right? And the knob above is going to control right and left simultaneously. So on the back end, I may need to have a potentiometer that will allow me to do biasing back and forth. Oh, look at that. That's a little tighter than... Well, they're going to have to be bent. I thought those would fit. I guess they're in as far as we can fit them. I really hope none of these things are too restricted to fit the pin in. But we measured the pins of the alpha that I have, and it doesn't have as many of these things at the bottom. I went to college, yes, to a 4-year college to learn electrical engineering. So is that going to be confusing? I don't think it'll be too confusing. Julian wants there to be three different controls on this. So your input, left and right simultaneously, will be controlled by these two, and you have the left and right here. So basically, this one will control these two, this one will control these two, and then down here, you have your overall volume into your headphones. And so what I want to do is on the headphone control, I want to use a high quality, I thought it would fit Bother 2024. Is that going to be my slogan? But I want to use a high quality headphone amplifier. It's a QFST chip. It'll probably be in place of this one down here. QFN rather, quad flat no lead package. And that does like big headphones. It's got like I think 120 dB gain, and it's a relatively simple like chip. I don't know if those are obsolete anymore. I've never made a mixer before. Mixers are interesting in terms of the schematic, because what you have is you have an input and then you have an amplifier on that input, and it can amplify or attenuate. You have an amplifier on that input, and then it just throws everything into left and right channels. Like everything is just on the same left and right trace. And then that left and right trace goes to another set of amplifiers and then to the output. That's it. That's all a mixer really is. It's interesting. Everything's being thrown onto a similar rail. Are we? Yeah, no activity on YouTube. Okay. Look at you guys. All the YouTubers left. They had to go home from work. I don't know how these are going to work out. These are going to be very annoying to work with. These very minimal pads for everything. But, you know, we'll try. We'll give it a try. Okay, so cutouts in the board. I could either do that with the part, or I could do it with the PCB. If I'm going to be doing more of these two, you know, these tiny synthesizer modules, which I probably should because it's Julian's favorite form factor, I need a part that's going to match up with them. So YouTube was delayed by God only knows how many minutes. Really? I guess I haven't found an update for the dual streaming software. It was kind of janky when I implemented it, and it may just still be janky. Yeah, I don't know. I don't know what the delays are like over there. Okay. Well, I'm happy to have you on Twitch. It's perfectly fine. Let's make these parts cut out the board instead of the board cuts by us. We can make it so that our parts are going to create those little slot cuts as necessary. So what I'm going to do is go into the part, the knob, once again. Once again, I'm asking for your knob. No, that's a no. You can't have it. We go all the way back to here. Actually, yeah, mechanical. No, mechanical's still open. So actually, we can go directly just into mechanical. Mechanical managed. And we're looking for our pot. These are, I think, different ones, right? Alps, pot, vertical. Oh, see, I'm looking at parts. I want to look at components, which is this first little category over here. Twitch is slower. Huh. Yeah, I don't know what it is. YouTube's doing all kinds of shenanigans because we're getting towards the end of the year. How's it going, Short Lurker? How you been? So we're going back into this part, into my Alps pot, narrower. Actually, this is the most narrow, and it is the bent one. And could I get away? No, I can't get away with moving them vertically or horizontally anymore. They are in, I think, what is the most minimal space from center. Doing all right. These jumping platforms, we don't know where he is anymore. He's right behind you. So I want to edit this footprint. I just double click it. I tried to double click it. Nope, don't let me do it. All right, let's open up the whole part. And then I'm going to go from here to here. Double click that. There we go. That was the right order of operations, I guess. Okay, so I want to make this cut into the board. I want to make a cutout. What I saw on the original footprint was that they had the two pads for the legs and Tor-based. They had a light blue outline where it was going to cut out the board. So light blue outline, not Route 6. And it wasn't reference. Oh my God. There's a lot of stuff here. I don't know if maybe I should be doing this with the board edge, or if I do this with a layer. But if I'm going to be doing more of these, then I want it to kind of go with the part. Holes, milling, drills. Oh, there it is, milling. I guess it was light bluish gray. That still looks pretty gray. Milling layer, huh? And if I do that, what should I do? Before it was just a line. And if I draw a square line, maybe that would do it. And I guess I could do a little like cut in for it, but for now we can just keep it square and see what happens. So if I come in from here and I go around this just with a standard line, is that going to work? And then how do I replicate it on the other side? Can I mirror this? I don't think I can mirror it. Mirror. Okay, the mirror tool didn't pull up anything. It feels a little awkward. Does it need a line to mirror it on? I'm going to escape the mirror tool because I don't trust the mirror tool. I'm just going to control click, copy, paste, and we'll just put this thing in over here. I don't think I trust it at all. I just want to make sure that the numbers here are the opposite numbers. Oh God, I'm not going to do that. This is not going to be the most even thing in the world if I don't do this carefully. 4.0455555. Like that. And then, oh no, that's the one that yeah, that's the one that I just got. I get this one now. 5 point, Jesus. The numbers are crazy. I'm sure there are more sensible numbers that I could put in here, but. Now, theoretically, these are at the same height. 0.5885, blah, 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 blah. Yeah, that looks about right. Jeez. Print screenshots. Here, schmear. It's electronics. It's not like you need precision. All right. Well, I guess we'll have to figure out what the numbers are using the measuring tools. What I'm going to do is I'm going to update this part. So I'm going to hit save, and then we'll do the same process of hitting all this stuff. I wish this was a little bit more streamlined, but it's all we can do. So there we go. Manage, upload, merge. Footprint, newer button with local edits. Retain the local footprint. What do you, it's okay, yeah, do that. I like that they show it to you. Yes, that's, no, don't copy the, just click OK. Oh my God. It's like, I'm trying to get you to overwrite it, please. Sorry for the lurking. I've been working in Fusion 3 F3D. What do you all think of the new manufacturer workspace? I have not tried it. I have not tried it. I do not know what it is like. I would like to try it because apparently my copy was updated to have it. And from what I hear, it's pretty good. But that's only what I hear. So I don't have any personal experience. Okay, there was that. Now we added that to the mill layer. So this is gonna get milled out of the board. I didn't back it up with any numbers. I don't have any numbers on this. So we're gonna have to get some numbers and come back in and redo all of that, retool our stuff. So let's update design with all libraries used. Oh my God, there was a modification. Dear God, who would have thought? So let's switch into that. This could use, the whole process could use a little bit of massaging. We may not actually get that may not go all the way out to the edge of the board. I may need to extend those little boxes a little bit. Now we can't see it here unless we view the actual, all the layers of the part. So if I go to the 3D design and it pushes it, it's gonna get a little herky-jerky for a second here. Just a little bit. Come on, buddy. I print terms of service pages. That's interesting. That's a good habit to be in, I suppose. Okay, so did it not do anything with the mill layer? It did not do anything with the mill layer. I thought that's what it that's what it did on the previous one. It actually made a cutout on the layer for that. So I guess that's not what the mill layer is for. Okay. So not mill. Definitely not cream. Unrouted dimensions, pads, route 11, B values, B stop, B glue, B test. Restrict, no. Keep out, no. Drills, holes, and milling. So I went to milling and it didn't do anything. The docu layer, the map layer, the plate, no. So layer for board cutout. Maybe they have an explanation of the layers. That just takes us to the page. Do we get more information? Instructions for ordering. Try to close some of these extra things. All right, let's see. Stencil assembly layout. How do I place a layout order? Oh man, there's so many pop-ups, right? PCBA, PCB layout facts, total number of pin pads, I export the project. I don't think any of this is quite answering my... all the information is here. I just need to find it. Technical guidelines. Via panels and PCB difference tolerance. Nice. Common compatibility, technical guide making solder overflow slots. Prevent breakage in narrow board areas. Chamfering gold fingers. That sounds like something else. I don't know what that sounds like though. Cross-shaped slot holes. No, we're not doing any of those. Imposition. I don't know what that is. Edge plating. No. Impedance. No. VGA designs. Panelization. I mean, panelization might have some information. We're not doing V-cuts. Yeah, you got to be front with them and tell them how many designs you have. V-cut can only be blah, blah, blah. What layer are these on? What layer is that on? I don't want to do the board. I don't want to edit the... I mean, I will eventually edit the board to be like curved on the edges just for fun, but I want to be able to do the side cutouts, and I could do that on the PCB, but there's a way that I can do it in the part. I want to see what layers I'm supposed to be using. Common mistakes when using Altium. Not quite my flavor, but... What? Slots missing. Designed on the drill guide or drill drawing layer, not included in Gerber output. What about edge cuts? I guess if that has to be on like the specific drill layer, then I might be having troubles. I might have to just do it manually and do the board edge to kind of come in by like a half. And this is all per Altium, and I'm not using Altium, so. Keep out action selector slot. I mean, outline, I guess they want it to be in the board outline, so if I lock in the position of everything, I'll need to just put it on the outline layer instead of on some other layer. See, what happened before is there was like a square slot for the pin to go through, and it actually routed that out of the board somehow. I don't know how it did it, but it was a square that was on a different layer. Let's look at an example and see if we can see what's going on here. It was a different part, and it had a different like thingy. So I can go to Alpspot narrow. Let's take a look at that. So here, there was something on, see that blue right there? There's a square, and I think that was somehow cut out of the board. So I don't know what that layer is doing. We're gonna not save this. It is on the milling layer. Okay. Front breakage and narrow board edge, aluminum substrates, how to generate Gerber and drill files, what cases will be changed, panelization, thermal electric, instructions for ordering, quality complaint. Prevent breakage in board areas. How about that? Milling. Narrow, unsupported board areas are prone to breakage, deformation during the process. As a rule of thumb, there should be no areas of PCB drawn narrower than 2 mm after milling. In order for the board to have sufficient mechanical strength, value should be increased for very large boards where more mechanical support is required. Why did my milling layer not do anything then? Maybe I don't think the milling layer is recognized by... Laminated file preparation. Easy EDA, JLPCB. I think JLPCB might have an auto like job that you can run that does all the right files. I just want to know what files they're expecting. Oh, here we go. Top silk screen, solder mask, top layer, inner layer, bottom solder mask, bottom silk screen, drills, board outline, V-slots, etc., and vias which need to be filled with resin or copper, and then drill map, stiffener layer. What is that? Direct heatsink pad. Okay, so yeah, we'll have to do it with board edge specifically. We'll have to do it using the board edge tools. Oh man. Whoa, what is this giant thing that's... Everything is green. What's going on? Okay, so let's go back to the 3D model and figure out what our board width is going to be. I'm going to Control Z my way out of that, and let's go to... Oh, it's going to want me to save it anyway because I screwed around with it. Well, I guess I'll just save it like this. Back to where we were, and let me undo what I did to the other one. So this would be the super duper narrow Alps pot. Super duper narrow. Where is that one? Narrow bent. And we'll just get rid of these. They didn't do anything. I guess the bill layer is a myth. Wouldn't castellation apply? What is castellation? I mean, I guess if I wanted it to be plated, I could castellate. Yeah, so castellation is when you have a pin on the edge of a board and it has a conductive material plated onto it. It's like as if you cut the via, but a little ring doesn't fall out of it. So it's these guys. These little amogus here are castellated holes. You don't have to have that inner hole. You could just have the cut hole, and that would be castellations. What that allows you to do is lay it down flat on another PCB and solder it down. Technically, I could do castellated stuff. I don't know what the limitations are on them or if I'm going to pay for a lot of that. Did I just see activity? What has happened? Hold on. Something happened. Oh, pipe train. Nice. So castellated holes. Oh my God. Copper wall remains after milling. Locations A are drilled from the top side of the PCB. Bottom, arrows indicate the drill bit's direction of rotation. The bit's cut into the board. Drilling process for castellated. Plated slot, A and B. I see, so they're coming in with a mill. Board size 10 by 10, board edge to castellated pad 1. How in the world? Yeah, I don't know. I think I'm just going to do board cuts because I don't need the plate there. It doesn't need to be anything. I do not need the plate. I don't need to do multiples like that. Looks like I'd have to do a whole bunch of BS with the design too in order to get that to work properly. Yeah. The belt sander's hooked up. It's in the other part of the basement though. But I mean, what I could do is just like narrow the board for it. It just means if I move them at all, I need to move my little cuts in the board. Yeah, castellations are a pain for everybody. But I could do castellated slots on the edges and have those override the board in the same way, but I don't know about doing that. I don't think it's worth it. I think I'll just edit the board. So all these are back to normal. I'm going to stop. Every time I do this, it uploads to the cloud and everything. So I'm like the worst Fusion user. They're probably very mad at me for using all their bandwidth. This guy just keeps uploading. Oh my God. Waiting, waiting, waiting. All right, everybody's back to normal. Let's go all the way through the process and render the board, except that in the 2D version, we are going to cut in the board just a little bit. And for that, I need to actually go to my 3D model and figure out what the distance is between these. So right now, we are at a full 10 millimeter from board edge to board edge. If I go from here to here, we can subtract that number from 10, and now we'll know. So that is 9 millimeters from edge to edge. The board was originally 9 millimeters, and those fit perfectly. So we can take a 0.5 millimeter cut out of either side. Hold on, let's update this design. Library has modified the board. Yes, I know. Let's go to this, and nothing changes. Only now we need to put a 0.5 millimeter cut in approximately the location of those little ears, but I need it to be a certain length. So what's the length going to be? Wider than this. Ugh. The problem with doing it this way is I think I'm going to need a whole bunch of coordinates to do it, whereas if I just put a slot on the side of the board, 2 millimeter, okay. I don't know if it's really going to... Polyline. So take it from... Oh boy, this is going to be all kinds of messy. Let's just see what that does. I think that's going to really make a mess of things because I didn't measure anything. And I'd have to do it with all these coordinates if I did it that way. Well, let's just take a look. I'll have to figure out how I want to end up doing this in the end. That or I don't do it, and I just have to expand the metal on these parts in order to get them to fit. This thing's got everything against it falling into the right spot, though. I mean, yeah, I can refine that a little bit, and I don't know if their milling is going to be that accurate. It does work, though. I guess I could just place that over top of all of them. If we take this in, let's do from this side and grab those. Just hit Alt. I don't know if it's going to be able to do that complicated of a cut. And if it'll be able to line that up. It's going to be the numbers are going to be all messed up. They're going to be nasty numbers, terrible numbers. Is that all lined up? See, they subtly added little sketch tools to this. If you're drawing lines on something like this, they subtly added little connections to everything. Actually, this is not working, so we'll delete these. And then I'm going to do another polyline direct. You see how it put a little square in there and how it's doing like a little, the light blue symbol that it's putting on there. Those are guides that it's applying to these things. Yeah, it'll be the size of the end mill, and I think it's 0.3, but I'm not sure. That's what they said the minimum was. As long as there's something there, I think it'll be okay. It did not highlight that in a way that I thought it was going to. I don't know if... Did I break both of my cuts? I may have. Let's just check. I think I broke them. Maybe I need to close them. It's still thinking. We have no idea what's going on in the background, but I know it's thinking. I'll have to take a look closer about how they handle all this stuff. Oh, now there's nothing. Yeah, so it didn't recognize it as a board edge cut. Wonder why that is. Oops, click on the wrong thing. How did I break both of them? That's what I'm wondering. Oh boy. Okay, well, I'll have to see if I can incorporate that into the part or not. Wait, what's that? Was there like a midline on there? Weird. Must have added polygons to it. All right, well, before I ruin the board, I think we're done for the day. I've been streaming for a little while now. It's been four hours, and I have responsibilities for the dog and all the crap that's been going on today. I think the chimney thing happened in the background, so I don't have to worry about that anymore. But like I said earlier, the house has rats. So unfortunately, when things got cold, the rats came in from the forest and they said, this is a nice place, but that nice place is our attic. And it was my dog's milk bones that were too big, and we put them in a bin, and they got into them and ate them all. All of my poor puppy's milk bones. So I'm gonna go take her for a walk. I will be back on Tuesday. We may do more of this, or we may like try to find something that's a little bit less cerebral. We're gonna do a lot of this sort of AutoCAD Fusion 360 thing, and I will mark with a hashtag every time we do it. I am going to way overrun the limitations for the licensing. I'm gonna have like 1 million whatever credits towards doing it. Rat poison everywhere. Well, the problem with the rat poison everywhere is that they then die in the walls, and then you've got to smell them. So we've got to figure out what we're doing this November. November is going to be the anti-rat, the de-rattening in the house. Anyway, yeah, so we got that going on. This is a mixer for Julian. I need to figure out what the rest of the design is going to be, like in terms of the circuits. I have to order all the parts for the 303. We've got a lot to do. We're going to move forward and just get to these things, and then we can play with some cooler things like the disappointing visuals from that astronaut toy. Unfortunately, they didn't come through on camera enough for me, so we'll find some other fun stuff to do and keep the variety going. But in the meantime, we've got a couple more like software projects. So just got a good 5-hour session through this thing. I'm starting to believe that our stuff is going to actually fit, and that's kind of scary. So I'll continue and try to figure out what the design's going to be. Julian and Dave might be here on Saturday, but I will catch you guys on Thursday. I need to update the commands. I forgot to update the commands. Hold on. I always forget to update these commands. These are my end card commands, and they've got links to all of my social stuff, which I don't necessarily love, but you know, we got to do it. We got to do the social stuff. So the next stream is for the next command will be on Thursday, which is Halloween. I don't like streaming on Halloween. I don't have anything like special to do on Halloween. I wonder if I should skip Thursday and jump over to Friday, Saturday. No, we'll stream. I had a possum in the attic, ate a hole in the roof. Oh my god. Yeah, we're gonna have to get all of the insulation up there redone, which I guess means we'll get better insulation. This house was built in the 90s, so everything is like failing. So we'll get better insulation. They're gonna clean all of the wonderful rat pheromones from that area, because you know they're up there fighting and effing each other and just having a great old time in our warm attic. And those smells are going to make it more attractive to other rats. So in the future, even beyond when they were living here. So we may get a return from them. So what we end up having to do is have all that stuff rebuilt. It's really annoying. My old house was made in the 60s, got a new roof after I sell the hole. Damn, that sucks. That's a much more expensive thing than what we're doing. But feeding, fighting, and flatulating. Yeah, there you go. Here's the end card. I got we all moved over to Blue Sky, all the electrical engineer gurus from Twitter, just because we've had enough of Twitter's BS. So we're on Blue Sky, and that's where you can find me. Or you can always find me in Discord. I'm a little bit too connected to Discord. But I'm gonna go touch grass. I would suggest you do as well. It's a little chilly outside up here in the Northeast, but it's a good opportunity to stretch your legs, try not to get blood clots. Yeah, it is. It's very cozy so far. It's got that new social media smell. And so far, aside from the utter and complete like domination of furry media on the thing, it's pretty good. And if you don't mind the furry stuff, it's perfectly fine. The algorithm thought I was into some weird shit for a little while though, so I had to kind of like, I had to be careful about what I was clicking on. It'll get some weird ideas from you. But tile, brick, ceramic. Oh, really? 90s is a flat ceramic tile. Yeah, if you could chew through that. We should get a copper roof. No, we're just gonna put new insulation up there. Those guys know what they're doing. They'll clean the place out. They'll scrub it, get all the rat poop out of it, and then put in a new insulation. That's late in November though that happens. So I don't think it'll interfere with stream at all. But there's a lot of like setup stuff that we need to do, like vacuuming everything and cleaning and just finding all the food in the house, which is not that much. We had it in areas where it could be discovered, and the rats found it immediately. They also, the reason we know that they're rats is they chewed up a silicon dog treat mold. This is silicon mold, right? You mix up some good stuff for dogs, like, you know, whatever, little yogurt or something like that, and you put it into the silicon mold and you freeze it, and you got little dog treat shaped treats for the dogs. Like, oh, it's summer, it's hot. Here, have a little thing of yogurt, dog. And they're like, this is the best thing ever. Well, we have that mold sitting in the back of all the dog stuff in the garage, and the animals chewed it up, probably for bedding material. I don't think they ate it, but they chewed it up. And mice don't do that. Squirrels might. Birds definitely don't do that. So we're pretty sure that we have rats. Run the copper through the walls and the floors too. You can live in a Faraday cage. I already do. This is already a Faraday cage. I barely get Wi-Fi outside of the house. And the antennae are right there, and I'm over there, and I don't get Wi-Fi. It's crazy. Time to go build a humane rat catcher? No, we're beyond humane. They've done enough. Okay, we've got an exterminator on the job, all right? I'm going to be back. I'm not going to build a humane rat catcher. I don't need another project. I am up to here with projects, and I can't breathe. So we need to finish stuff. We need to work on the stuff to finish it. It's going to be a little while for everything. At some point, we'll work on Burn the Subs. I'm going to clean off that table because my friends are coming on Saturday. We will stream, and we will stream music stuff, and it should be pretty fun. But anyway, look for your account the other day on Blue Sky. Oh, it's showing some other guy. O-bother. They didn't let me use the underscore. I wanted O_bother, but I don't know if they don't allow underscores in usernames. So it's O-bother. But anyway, you guys can get the end card from before. I will be back. I will be back Tuesday. Wednesday, I will be ordering parts. That's what we do. And I will catch you guys then. Until then, you guys figure out where you want to go, because I'm not going to raid. I should, but I'm not. I will see you guys later. See you folks later. Now, guys is universal. Just, you know, I'll see you idiots later. Got 'em.